Right. So yesterday we have completed up to the polar vortex. So any major doubt? Polar vortex तक कुछ doubt है? Yes, no, something. No sir, no doubts. Clear? Very good, congrats. समझ में आ गया. आगे बढ़ें फिर. All of you ready? Okay, so what is the next topic that we have to take up? Air masses. और क्यों करने वाले हैं एयर मासेस? क्योंकि उसके बाद क्या आने वाला है? कौन सा? Temperate cyclones. So we have to cover this topic of temperate cyclones, and for understanding temperate cyclone we need to first understand air masses. ठीक है? So we can put the topic collectively as air masses, fronts and temperate cyclones. हाँ जी, बताइए. कल किसी और ने भी पूछा था ये क्वेश्चन. Who has asked? Sir, in case of polar front jet stream, the shifting is by 15 degrees. 45 to 70 लिखा है ना? क्यों लिखवा दिया? कैसा हो गया? Okay. I think somebody came to me with the same question after the class, and I said that these shiftings depend on the pressure belt, but beyond that, many times in some region they might shift, slightly more extreme. For example, when you do the pressure belt shifting, though I have said it shifts by 5 to 10 degrees, but when I'll talk of ITCZ, I'll tell you it shifts by 30 degrees. ठीक है? So in case of the same pressure belt, when we talk of it as ITCZ, we call that in India it shifts by 32, 33 degrees. ठीक है? So there can be exceptions, and that exception is something that we have factored in that jet stream. At some places it might shift by up to 45 degree. Does not mean it will always shift till 45 degree. Up to or till में अंतर होता है. You can score up to 100%. Does not mean you will always score 100%. ठीक है? So good. So आगे बढ़े. Any other doubt? No? Very good. So the topic that we write is air masses, fronts, 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 and temperate cyclones. Air masses, fronts and temperate cyclones. So, first of all, let us try to further understand what do we mean by air masses further. Why further? Because some very basic understanding of air masses we have already done when we were doing factors affecting temperature. In that we have understood one of the factors affecting the temperature of a region is air mass. How? We have seen two types of air masses, warm and cold. And if the warm air mass goes to a colder region, it can make the region relatively warmer and vice versa. ठीक है ना? ऐसा याद होगा. And there we have also written what is the air mass. Air mass could be a big parcel of air, ठीक है, having relatively uniform temperature and temperature condition. This is what we have written. ठीक है? So let us try to slightly further understand what do we mean by air masses. So just to get you a sense, let us say I take a region something like this, and let us say this is 90 degree and this is 60 degree and this is 30 degree. Okay, and this is the tropopause. And all of you, if you want, you can draw this. Okay, ताकि you get slight further sense of what do we mean by the concept of air mass. So this is a cold air mass, and let us say okay, something like this. Itna we have done. So first you draw this much and then we'll further see. Okay. Now in this air mass, what do we expect temperature? How do we expect the temperature to behave? For example, if I give you different regions, region 1, 2, and let us say 3 and 4. How do we expect the temperature to behave? What type of temperature should we expect at 1 and 2? Cold and temperature. Cold and similar. Can we say that the temperature at 1 and 2 should be cold and similar as compared to, let us say, 5, 6, 7 and 8. So I'm asking you at these 8 regions. Okay? Just think and give me answers. So at region number 1 and 2, we would expect the temperature to be cold, 1 because that's a cold air mass, and second, more so similar. But what about temperature at 1 and 3 or 2 and 4? Huh? Cold? Yes. Similar? Huh? At 1 and 3, should we expect the temperature to be similar? Why not? Why not? Because temperature decreases with height. तो वो rule तो रहेगा ही. You can't change that rule. Lapse rate, as you call it, normal lapse rate. So normal lapse rate will prevail. So within a air mass also normal lapse rate will prevail. आ रहा है समझ में? So it's not that if it's a air mass that the whole air mass has to have the same temperature. It's impossible. A whole air mass never has the same temperature. The temperature will be same or similar only at the same level. When you're talking of the same altitude, then only you can say that the temperature will be similar. Right? Many places it is written, temperature throughout the air mass is same. That is wrong. Temperature throughout the air mass is same or similar at the same altitude. So this is the first thing that you have to write here. Right? That temperature through the air mass is similar. It's never same first of all, it's similar. Temperature through the air mass is similar when seen at the same altitude. When seen at the same altitude. Full stop. With change in altitude, for example, with increase in height, change in altitude, for example, increase in height, the temperature will also change. Temperature will also change. At what rate? Normal lapse rate. At normal lapse rate. So vertically the temperature is never same. Vertically, the temperature is never same. Okay. How will it be same? Only horizontally. Alright. Second, will the pressure be same? Acha, horizontally, should the pressure be same in the air mass? Similar. Horizontally, should the pressure in the air mass, within one air mass, should it be similar or no? Why? No, क्यों? अगर temperature similar है, so we can expect the pressure also to be similar. Expect. I'm not saying it should always be, right? But we can expect the pressure to be similar. But vertically, will the pressure be same? No. So vertically, things are not, temperature and pressure are not same in the air mass or similar in air mass vertically. They are only similar horizontally. But now let me ask you, humidity, relative humidity. What should that be? Let us say relative humidity at the bottom is, let's say, 90%. What can you say about the relative humidity at the other heights? And I tell you that this is a wet air mass. अब क्या होगा? हाँ? Can the relative humidity remain same? What is relative humidity? The actual divided by capacity, and as the temperature will change, capacity will also change. So even if the actual is changing, doesn't matter, because relative will, if you are changing the numerator and you are also changing the denominator, that's perfectly fine. The constant might remain similar. Yes or no? ठीक है. So relative humidity throughout the air mass, vertical and horizontal, this is the only thing that will remain generally similar. Right? Relative humidity can remain similar, but not temperature and pressure. ठीक है. So this is the third thing. So did you write about the pressure first of all? Temperature तो आपने लिख लिया था. Pressure भी लिख लीजिए. Pressure also remains similar horizontally only. Pressure also remains similar horizontally only and not vertically. Not vertically. Full stop. The relative humidity remains similar throughout the air mass. Relative humidity remains similar throughout the air mass. Vertically and horizontally. Relative humidity remains similar throughout the air mass, vertically and horizontally. Is this okay? ठीक है. Now let us say the exam gives you a statement in the prelims. Air mass is a body of air in which the temperature, pressure and humidity are similar. नहीं, तब आपको इसको नो नहीं बोलना है. ठीक है, because then they are giving you a very general statement. Okay, so how do we generally define a air mass? A air mass is a body in which you do find similarity of temperature, pressure and humidity, but for each of them the conditions might vary. For example, when you talk of only temperature, then it is similar only horizontally. When you talk of humidity, it is similar only horizontally and vertically both rather. ठीक है, आ रहा है समझ में? But the general statement for air mass, that air mass is a body of air in which the temperature, humidity and pressure are similar as compared to another air mass. That's okay, perfectly fine. Right? क्योंकि अगर इतना भी नहीं बोलेंगे, then there is nothing like an air mass. आ रहा है समझ में? So a general statement like this is okay, but if they give you that temperature is similar throughout the air mass, horizontally and vertically, then it is wrong. So when they go into specifics, then you have to see specifics. But if they are giving you a very general statement, then that's okay. Doesn't matter. Is this all right? ठीक है, आगे बढ़े? Yes, dear. That's why I said, मैंने भी यही बोला कि I'm not saying that it will always be, because when you change pressure belts, it would change. Okay, mechanical conditions can also change, but when you compare two air masses, for example, when you compare this air mass with this air mass, in that case pressures will differ. Now let me give you an example. Let us say within this cold air mass, one region has 1040 and another has 1020. You can say this is varying, right? But from the average it is high, isn't it? When you go to a warm air mass, let us say at one place you have 1000, another you have 960. It is varying, but in general it is a low pressure air mass. Do you get it? So something like this. That's what I'm saying. Broader, you have to do those broader comparisons. All right. So abhi samajh mein aa raha hai broadly. Is this okay? Can I assume? Right. So do you understand these two air masses? So how will you differentiate two air masses? उनमें क्या different होगा? That you will say that these air masses are different. One, the temperature, the broad temperature of the whole thing would be varying. For example, if I take a cold air mass and a warm air mass, and if I see the average temperature, I can say that, let us say at mean sea level, this might have a temperature of 0 degree and the other one might have a temperature of 20 degree. So we can say these are two different air masses. Average I'm saying, and this 0 doesn't mean everywhere it is 0. It means horizontally maybe at some place it is -3, at another place it is 5. That's okay, doesn't matter. But average is 0. Do we get it? So this is a warm cold air mass, the other one becomes a warm air mass. Similarly, we can talk of in terms of humidity, a dry air mass and a wet air mass. Is this all right? Alright, Sanjay? Very good. So now, which are the different? So once you understand air masses, then you have to talk of the different air masses on Earth, the major different air masses on Earth. Alright, so please write that for our purpose, we classify air masses. For our purpose, we classify air masses on the basis of temperature, within bracket latitude, because latitude and temperature are related. Temperature, which means latitude, within bracket latitude, and second, so A, temperature, which means latitude, and B, relative humidity, within bracket continentality or maritime. So when you say relative humidity and you are saying continentality and maritime, which one will be dry and which one will be wet? Continental will be and maritime will be wet. Very good. Now same ways, if I ask you in terms of latitude or temperature, which one do you expect to be the coldest? Which are the regions that you have learned of? Polar region. Let me give you three regions. Okay. So I give you a region like 90 degree and surrounding, then 60 degree and surrounding, and 30 degree and surrounding. Right. So which one do you expect to be coldest? 90 degree. And second? 60. And warmest? So what will be 60 degree with respect to 90 degree? And the same 60 degree with respect to 30 degree? That's it. Ho gaya. Itna hi hai. Do you get it? So that's it. We have to do only this much. Air mass have different other classifications also, but we don't do it because it's not given in NCERT, neither given in GC Leong, never asked in exam. Right? Optional mein hai, wo wahan kariye. Right? But for our purpose, we have to do only this. Is this perfectly fine? Aa raha hai samajh mein? ठीक है? Very good. So now let us try to draw and understand and write further. So I hope वो लिख लिया आपने in terms of temperature and this thing. Did we? Okay. So you can write in terms of humidity. In terms of humidity, we call or we name, not call, we don't call, we name air masses as M maritime and C continental. And if you want, you can write which would be relatively wet and which will be relatively dry. Maritime and continental. Alright, ठीक है. And then in terms of latitude, now here you have to slightly remember, थोड़ा सा memorize करना पड़ेगा, हल्का, not too much, but so latitudes are 90 degree, 60 degree, 30 degree, okay, and 0 degree, let us say. right? Now 0 degree बनाया है, we don't need it. So the air mass which will be around 90 degree, okay, for example, let us say this is the earth, ऐसा, okay, and the latitudes are somewhat like this. So the air mass that you have around this region, around the pole, ये वाला, यहाँ पे, okay, how do you expect that air mass to be? Cold, okay. So this is, and let me draw the continent also in the whole big image. So it's something like the continent. Please do draw along with me. Ocean, something like this. Okay, so there's a big continent that we have drawn in the middle, and then we have drawn the oceans on the two sides and different latitudes. ठीक है? So the air mass that we have around the pole, this region, right? This one will be the coldest air mass. We know this, and we call it as Arctic or Antarctic air mass. Arctic or Antarctic. So you just write A, right? Because both of them are represented by the capital letter A, and that capital letter A stands for Arctic or Antarctic, and that air mass is around 90 degree latitude. Okay, and this will be the coldest of all air masses, coldest in terms of temperature, right? Then when you come to the 60 degree to 30 degree, that region, the air mass which is around 60 degree, what should we call it? 60 degree के around क्या होता है region? Subpolar type, है ना? So here we call this air mass as polar. अब ये थोड़ा सा अलग है, right? Because you don't expect this air mass to be called as polar, but we call it. और यही आपको याद रखना है. The air mass which is around which region? 60 degree region is called as polar, because the air mass over 90 degree is called as Arctic or Antarctic. ठीक है, तो जो रियल में 90 पे है उसको हम Arctic Antarctic बोलते हैं, इसीलिए the one which is around 60 we call it as polar. Is that okay? ठीक है, and draw it as I am drawing. So it will go slightly pole equator wards of 60 degree also, but we still call it as polar air mass. Is that okay? ठीक है, and the polar air mass can be over continent and it can also be over ocean. यहाँ पे भी हो सकता है ना, ठीक है. So which one will be maritime and which one will be continental? On the continent it will be continental polar, and on the ocean it will be maritime polar. Do we agree? ठीक है, and in the Arctic Antarctic one, उसके अंदर can you have polar and continental? Sorry, can you have continental and maritime in this one? Why? Because there is never any water body at the pole. वहां पे कोई water body नहीं होता है, so we can't have the maritime. So which one will we have? Only continental. So in this region you will only have continental Arctic or continental Antarctic. No maritime Arctic or Antarctic. Why? Because you don't have a water body in the pole. है ना, पोल पे जाके वहां कोई वाटर बॉडी नहीं मिलता है हमें, इट्स फ्रोजन. ओके, सो वी कॉल इट एज कॉन्टिनेंटल. व्हाई? बिकॉज देयर इज नो वाटर, राइट? कॉन्टिनेंटल आर्कटिक और कॉन्टिनेंटल अंटार्कटिक. इट इज अ वाटर बॉडी बट इट इज अ फ्रोजन वाटर बॉडी. ठीक है, एंड हेयर वंस यू कम टू 60 degree देयर यू स्टार्ट फाइंडिंग लैंड एंड यू ऑल्सो स्टार्ट फाइंडिंग ओशन वाटर बॉडीज. So the water body one you call as maritime polar, the land one you call as continental polar. Is this okay? ठीक है. So how many air masses done till now? Number wise. Arctic Antarctic as 1, then continental polar as 2, maritime polar as 3, and दूसरा side भी maritime polar ही है. Then when you come to 30 degree latitude, 30 degree and slightly south, what do you find? Which air mass do you find there? क्या मिलना चाहिए? Warm. So this will be a warm and we call it as tropical air mass. Subtropical है तो उसको हम tropical air mass बुलाते हैं. And it can be over continent or it can be over ocean. So what do we call tropical air mass? 30 degree and less. We call it as tropical air mass. ठीक है? Clear? And tropical air mass can also be oceanic or continental. So what will we call? The one over ocean is maritime. The one over continent is continental. Something like this. So how many more air masses done? 2 more. So total कितना हुआ? 5. Okay, so when you see the globe, for our exam perspective, there are 5 types of air masses. 1 in the Arctic, Antarctic, 2 in the polar, maritime polar and continental polar, and 2 in the tropical region, maritime tropical and continental tropical. Is this okay? आगे समझ में? So that's it. This is your air mass. Any major doubt? पक्का? Clear है? Okay. So this is how you get it. And once I have shown you, schematic diagram, then we will see over a continent also. वो भी देखते हैं अभी. But is this much drawn? So should I show you a similar thing over a continent? ये देखिए. Right? Which continent is drawn in the backdrop? ध्यान से देखो, दिख जाएगा. North America. So this image is showing you air masses around North America. So can you see the continental Arctic? दिख रहा है? कहाँ पे है? ऊपर, around Canada. The northern part of Canada you find that continental Arctic air mass. Then can you see the continental polar? है ना? Around 60 degree. I have drawn those latitudes also for you. So around 60 degree you find continental Arctic, continental polar and maritime polar over the oceans in the Pacific and the Atlantic. And similarly, when you come to tropical region, 30 degree and south, 30 degree and equatorwards, there you find maritime, tropical over the oceans and continental, tropical over the land, that Mexico wala region. Can you see? ठीक है? So this way you have different air masses. Is this clear? Broadly, आगे बढ़ सकते हैं? Very good. So once you understand different air masses and their effect, we have already seen one major effect of air mass will be a changing temperature. And similarly, if the air mass is humid, what will that do? It can bring rainfall. And if the air mass is dry, it can reduce the probability of rainfall. समझ रहे हैं हम, है ना? Simple. So good. This is your air mass story. Now let us come to, so air mass done. Now should we, so if you want you can write that one last line. Temperature wala part we have already seen. You can write the relative humidity of air masses. Relative humidity of air masses can affect, relative humidity of air masses can affect the probability of rainfall. Affect the probability of rainfall, and the absolute humidity will affect the, and the absolute humidity of air masses will affect the what? Amount of rainfall. Very good. Amount of rainfall. ठीक है? So with this, air mass topic is over. Right? Now after air mass, what is the next thing? Fronts. Fronts है ना? So fronts लिखिए, heading लिख लीजिए. सुन लिया बेटा? एक ही बार में सुन लिया. Don't worry. Just give me a second. Right? So write that subheading as fronts. अच्छा, मैं आप लोग को ये बच्चे बुला लेता हूँ, बुरा तो नहीं लगता है ना? पक्का, perfectly fine. कई होते हैं सर हम इतना grown up है, आप अभी तक बच्चा करते रहते हो. हाँ, प्लीज ट्रीट अस एज एडल्ट्स. तो ऐसा तो नहीं है ना आप लोग के साथ, मतलब होपफुली आप वो फेस पार कर चुके हो जब आपको प्रूव करना पड़े कि आप एडल्ट हो, है ना। जब थोड़ा बच्चे होते हैं तो ये फाइट होता है ना। अभी मेरा घर पे ये फाइट चलता रहता है, आई एम नो मोर अ किड, आई एम अ यंग एडल्ट। अब 12 साल में यंग एडल्ट हो गए तो मुझे लगता है यार अब क्या करें, मतलब यू नो कन्फाइंड। सो दैट्स व्हाई आई हैव टू आस्क। कई बार मेरे मुंह से गलती से निकल जाता है बच्चे, सो आई होप यू डोंट माइंड। ओके, सो यस, सो लेट अस कम बैक टू दिस। सो आई वाज सेइंग फ्रंट एंड योर डाउट बिफोर दैट, यस। कैन वी कॉल रॉस्बी वेव एज एयर मासेस? रॉस्बी वेव कितना वाइड होता है? अच्छा, डायमेंशंस हमने नहीं लिखा ना, दैट वुड हैव गिवन यू अ बिट ऑफ सेंस कि हम ये बोल सकते हैं नहीं, ठीक है, तो वो भी लिख लेते हैं। वेरी गुड, मे बी फ्रॉम हिज conversation we get this sense. What should be the size of air masses? By the way, I have given you hint. The hint is already there on the board. Previous वाला diagram. हाँ, कितना width कितना होना चाहिए air mass का? हाँ, around 2-3,000 kilometer is the maximum width, है ना? What is the height? Height up to tropopause, that you can see. ठीक है, so the horizontal size dimension of the air mass can be a few thousand kilometers maximum, right? And the vertical height can be up to tropopause maximum. Is that okay? On Rossby wave कितना बड़ा होता है? वो तो पूरा अर्थ के ऊपर ही ऐसा चक्कर लगा रहा है, तो कैन इट बी अ एयर मास? और दूसरा चीज, एयर मास कहां से कहां तक होता है? सरफेस से। और रॉसबी वेव किधर होता है? ठीक है, तो कुछ क्वेश्चन जैसे आते हैं तो यू हैव टू आल्सो स्लाइटली थिंक, क्योंकि ये सारा क्वेश्चन एग्जाम में भी आ सकता है, राइट? सो यू हैव टू स्टार्ट थिंकिंग कि क्या आंसर होना चाहिए। इज दैट ओके? राइट, सो होपफुली व्हाट इज द आंसर फाइनली? आर रॉसबी वेव सेम एज एयर मासेस? नो सर। ठीक है, ओके, वेरी गुड। सो लेट अस कम टू द नेक्स्ट पार्ट, फ्रंट्स। सो व्हाट इज द मीनिंग ऑफ द इंग्लिश वर्ड फ्रंट? फ्रंट का बहुत सारा मीनिंग है। फ्रंट, वन द सिंपलेस्ट मीनिंग इज फ्रॉम द फ्रंट। ओके, सो आपका कोई आगे खड़ा है तो उसको हम फ्रंट बोलते हैं। अनदर मीनिंग ऑफ द इंग्लिश वर्ड फ्रंट आपने सुना होगा इन टर्म्स ऑफ, लेट अस से पॉलिटिकल टर्म होता है ना फ्रंट, तो उस फ्रंट का क्या मतलब है? बाउंड्री, राइट? सो समथिंग लाइक बाउंड्री, राइट? और सम काइंड ऑफ डिलीनिएटिंग थिंग विच सेपरेट्स वन फ्रॉम अनदर, राइट? सो फ्रंट बोलते हैं ना कि इंडिया का चाइना के साथ फ्रंट है ना, या उसके साथ, या हमारे फ्रंट के ऊपर सोल्जर्स खड़े हैं। ओके, सो फ्रंट मींस बाउंड्री। नाउ व्हाई डू यू कॉल इट अ बाउंड्री? क्यों बोलते हैं? बिकॉज इट सेपरेट्स वन रीजन फ्रॉम अनदर। सो व्हेन यू टॉक ऑफ द फ्रंट दैट वी आर टॉकिंग ऑफ, वो कैसा फ्रंट है? विच इज सेपरेटिंग इंडिया फ्रॉम पाकिस्तान। व्हाट आर इंडिया एंड पाकिस्तान? दे आर पॉलिटिकल एंटिटीज, है ना? What are they? They are political entities. They are not geographical entities. If you go in space and try to look at the Indian subcontinent, वहां आपको इंडिया पाकिस्तान कुछ नहीं दिखेगा, वहां आपको कोई कंट्री नहीं दिखेगा। You must have heard many space, you know, people going to ISS, वो क्या बोलते हैं कि वहां जाकर के the whole earth looks one. There is no boundary. कुछ दिखता ही नहीं है बाउंड्री। That's when you start realizing कि ये तो एक ही अर्थ है। When you are on the earth, हमें वो कभी फीलिंग ही नहीं आता है कि वन अर्थ है ना? बट व्हेन यू स्टार्ट गोइंग टुवर्ड्स स्पेस एंड देन यू सी योर अर्थ, देन यू रियलाइज ओहो ये तो एक ही है और छोटा सा ही है ना? राइट, सो वी मस्ट प्रिजर्व, एंड टिल वी आर ऑन दिस बॉर्डर पे, यू नो, बाउंड्री और फ्रंट के ऊपर बम लगा लगा करके रॉकेट मारते रहते हैं, दो चार गलती से भी गिरा देते हैं। ठीक है, ओके। So what is a front? Front is a boundary which separates two regions, and depending on what kind of region they are separating, on that basis you call that front as a political front or whatever front. Is that okay? Now what is the India and Pakistan front separating between the two regions? There are two different political entities which are governed by different rules, right? On both the side of the front there are different rules, different characteristic, and are they similar or they are different? They are very different. If they were similar, right? And if they were friendly, then the front will be not there or a weak front, जैसा इंडिया नेपाल फ्रंट है, ठीक है? वहां पे आप जाइए, आप आराम से क्रॉस करके उधर जाओ, घूम के आ जाओ, डजंट मैटर. व्हाई? ऐसा नहीं है कि वो दो पॉलिटिकल एंटिटीज उतना स्ट्रांग नहीं है, बट द डिफरेंस इज नॉट सो स्टार्क. ठीक है? द डिफरेंस बिटवीन देम इज नॉट सो स्टार्क. वी डू नॉट वांट टू मेंटेन दैट स्टार्क डिफरेंस. ठीक है? देयरफॉर द बाउंड्री इज व्हाट? Something that you can pass through. Okay? Whereas when you go to, for example, if you go to, you know, if you are traveling in India, I give this example generally, और आपके पास आपका आधार कार्ड है और कोई भी पुलिस वाला रोक ले या कोई आर्मी वाला, so he might ask you if he doesn't understand where you are from. So what will he ask you? किधर से है? What will you do? आधार कार्ड दिखा दोगे और इलेक्शन कार्ड और whatever card you are, and then the police वाला और the army वाला will say ठीक है जाओ. एंड यू क्रॉस द बॉर्डर, उधर जाकर के पूछा किधर से, और आपने आधार कार्ड दिखा दिया या इलेक्शन कार्ड, तो क्या बोलेगा? जाओ, आओ. वो जाओ नहीं बोलेगा, इधर आओ. नेक्स्ट क्वेश्चन, इधर कैसे आया? आई होप यू अंडरस्टैंड. ठीक है? सो ऑन द टू साइड्स दिस इज द डिफरेंस. इज दैट ओके? नाउ सेम वेज please come to this diagram. So basically what I was trying to make you understand is that one, what is a front? A front is something that separates two regions having different characteristics. And more the different the characteristic, more stronger the front. And if the difference between the two regions is not so stark, then the front will be not a very strong front. Then you don't call it as a strong front, you call it as a permeable front. Through which you can pass. Is this clear? Very good, right? Now, please see at these air masses. Now, as we have seen, one, there is a difference. So, what kind of entities are these? These are atmospheric entities, geographical entities. Okay, so there you will talk in terms of geographical characteristic. Which characteristics are different between two air masses? So, you can imagine these air masses as regions, the way you imagined India and Pakistan. ठीक है? एंड व्हाट काइंड ऑफ कैरेक्टरिस्टिक्स आर डिफरेंट इन देम? टेम्परेचर, प्रेशर एंड ह्यूमिडिटी. ये तीन चीजें डिफर करती हैं एयर मासेस में. इज दिस ओके? सो वेयर द डिफरेंस इज लेस, फर्स्ट ऑफ ऑल कैन यू अंडरस्टैंड देयर वुड बी अ फ्रंट आल्सो बिटवीन द एयर मासेस. व्हाट विल बी द फ्रंट? फ्रंट विल बी द रीजन सेपरेटिंग वन फ्रॉम द अदर. अच्छा, एक और चीज बताओ, इंडिया पाकिस्तान का जो फ्रंट है, इज दैट ओनली अ लाइन और इट इज अ स्पेस? इट इज अ शीट काइंड ऑफ अ एरिया. व्हाट डू यू थिंक? वो सिर्फ लाइन है या वर्टिकल भी है? वर्टिकल भी तो है ना. ऐसा तो है नहीं कि जमीन पे लाइन से क्रॉस किया तो पकड़ लेंगे, थोड़ा कूद के गए तो जाने देंगे. आपने तो फ्रंट को टच नहीं किया, फ्रंट तो सिर्फ लाइन ही था, है ना. दैट होल थिंग इज फ्रंट. आई होप यू अंडरस्टैंड. ऐसा नहीं कि थोड़ा ज्यादा ऊंचा जंप मार लिया तो जाने देंगे उधर को. आई होप एवरीवन इज क्लियर. So front is that whole vertical space. Is that okay? So same way as when you talk of front between air masses, it will not be a line, but it will be the vertical space between air masses. Is that okay? So the whole vertical space between the air mass is one, the front, the region which separates one air mass from another, and hence it will be a vertical space. One. Second, if the temperature differences are very strong, front will be strong. If the humidity difference is very strong, again strong. And if the differences are very less, and if there is no difference, no front. That's it. Difference है ही नहीं तो front भी नहीं है. आ रहा है समझ में? Is this understood? Now, what about mixing of the things within the region? The air, what is there within a air mass? Air. So can the air mass mix within itself? Yes or no? It can. But will it mix across the front? For example, do people from India mix across without permission? नहीं, है ना. You can't cross the front and go around. ठीक है? Same ways, air also will not mix around. Now, have you ever experienced this? Does it easily mix or no? If you have air of two different temperature, does it easily mix or no? अच्छा, लिक्विड, चलो फ्लूइड में बात करते हैं. लेट मी गिव यू एन एग्जांपल. in terms of fluid. So do fluids of two different temperature easily mix, or do they not? You have to mix them up. What is it? ये हुआ है कभी आपके साथ? कब हुआ है? हाँ, ऑयल वाटर अभी विंटर में हुआ होगा, नहाते होगे जब, सब नहाते थे? नहीं, ये सवाल पूछना पड़ता है, मतलब ऐसा आई कांट टेक इट फॉर ग्रांटेड कि हाँ सबके सब नहाते थे. बहुत सारे होते हैं सर, दिवाली पे आखिरी नहाया था, होली के बाद नेक्स्ट नहाएंगे, बीच में नहाते वाते नहीं हम, है ना. वाई शुड वी वेस्ट वाटर इन विंटर, एंड एनीवेज इतना ठंड है. सो व्हेन यू टेक बाथ इन विंटर, है ना, सो यू हैव अ यू आई होप मोस्ट ऑफ यू आर मिडिल क्लास लाइक मी, है ना. तो आपका ऐसा नहीं कि घर में 5-6 शावर लगा हुआ है, सारा मिक्स विक्स किया, आराम से पानी बह रहा है, बकेट में नहाना पड़ता होगा. एटलीस्ट व्हेन आई वाज अ स्टूडेंट तो ऐसा ही करना हो, एक बकेट होता था, एक मग होता था, उसको लेके जाते थे, है ना. देन देयर वाज अ हॉट वाटर टैप, उसमें से एक ही अमाउंट, फिक्स अमाउंट था, उससे ज्यादा निकाल नहीं सकते थे. निकाल लिया तो पानी खत्म, फिर वो ठंडा आता था, बिकॉज द गीजर वाज स्मॉल. ठीक है, सो यू जनरली फिल द मग विद और दैट बकेट विद हॉट वाटर, एंड देन यू टेक इट टू अ कोल्ड वाटर थिंग, और वहां पे जाके कोल्ड वाटर मिला के नहाते थे. याद आ रहा है कुछ? नहाए हो ना, मतलब दैट्स व्हाई आई आस्क्ड यू. अभी ये विंटर पिछला नहा के निकला है या ऐसे ही निकला है? नहा के निकला है. वेरी गुड. सो व्हेन यू पुट दैट कोल्ड वाटर टैप ऑन, है ना, एंड लेट अस से द बकेट इज फुल, राइट, और टू द एक्सटेंट दैट यू वांट टू, उसके बाद सीधा एक बकेट उसमें से एक वो मग पानी निकाल के बॉडी पे डाल सकते हैं. इफ यू जस्ट टेक, लेट से थोड़ा सा ऐसा मग निकाल के डाल दिया, क्या होता है? ईदर यू फाइंड इट हॉट और यू फाइंड इट, एंड व्हाई? पानी तो उतना ही है ना, पानी तो वही है ना, बट स्टिल द वाटर इज नॉट यूनिफॉर्मली हीटेड. देन व्हाट डू यू डू? तो जो थोड़ा सा सीजन नहाने वाले हैं, सीजन मतलब जो हर रोज नहाते हैं, what do? They will not directly take a mug and put on their body. What will they do? वो पहला मग से ऐसा धीरे धीरे हिलाएंगे. Sometimes they also have a डंडा साइड में, वो धीरे धीरे डंडा से ऐसा ऐसा हिला के मिक्स करके प्रॉपरली यूनिफॉर्म हो गया. देन ग्रेजुअली चेक करेंगे हाथ पे, फिर 2-3 बार ऊपर वाले का नाम लेके. यस और नो? याद आ रहा है? ठीक है. माई क्वेश्चन इज, इन दैट बकेट द वाटर इज सेम, आप तो सिर्फ मिक्स ही कर रहे हो. Why didn't the water mix on its own? This is a characteristic of warm and cold objects. They generally do not mix readily. And it's not only temperature, it is density also. Objects of different temperature or different density do not mix easily. This is a rule of fluids. ठीक है. Now this rule I have to make you understand through all this example, नहाने वाने का. But the idea is to understand what is the basic characteristic. So the basic characteristic is objects or fluids of different temperature and different density do not mix easily. Is that okay? So this is one rule that I want you to write somewhere in your copy. जिनको पता है वो तो अच्छा है, जिसको नहीं पता should write. ठीक है. So what do we write? Fluids of different temperature or density. Fluids of different temperature or density do not mix readily. Okay, you might have seen this with ink and water also, right? If you take your ball pen wala ink, right, or fountain pen ink also, and you drop 1 or 2 drops of that ink in a glass of water, you will see that the ink will go on sinking. It will not spread, right? It will gradually sink to the bottom and remain there. And to mix it, you have to stir it. देखा है? Right? Why? There the temperature is not different. What is different? The density is different. So when that bathing example was for temperature and this example is for density. Are you समझ में? So this is clear. So now come to this. In this case, what all is varying? Temperature, pressure and hence density, and humidity and again hence density. क्योंकि humidity से भी तो density vary करेगा ना? Do we agree? So if the temperature or density are very different, then the air masses are distinct and the front will be strong, which means will there be mixing between them? No. Okay. And if the air masses are similar, okay, for example, there is one cold air mass and next to it is also a cold air mass, similar type. In that case, the front will be strong or weak front? Weak front. And then the mixing can be relatively easily. Right? Is this okay? आ गया समझ में? So should we write these characteristics of the front? अभी तो हमने front का थोड़ा characteristic समझा है ना, लिख भी लेते हैं. So let us write. What is the front? First, what is the front? Front is the region. Front is the region which separates. Front is the region which separates one air mass. Region which separates one air mass from the other air mass. From the other air mass. Full stop. The more distinct or different the air masses, the more distinct or different the air masses in terms of more distinct or different the air masses in terms of what? Temperature, pressure or humidity. In terms of temperature, pressure or humidity. Comma. The stronger will be the front separating them. Stronger will be the front separating them. And hence lesser the chance of air crossing the front to mix in the other air mass. Lesser the chance of the air crossing the front, right? Air crossing the front and mix in the other air mass. Full stop. Is this okay? So strong fronts, we do not allow air to cross and mix. And on the other hand, weaker the front, easier will be the mixing. So if you want, you can write that also. On the other hand, weaker the front, easier will be the mixing across the front. Mixing across the front. In which case will the front be weak? When the air masses are not very distinct or different. ठीक है, तो वो हम पहले लिख चुके हैं, so there is no point repeating the same thing. Alright, clear. So front भी समझ में आ गया. What is the front is clear to everyone, right? And is the front a line? No, it is a region. So now if I ask you what should be the characteristic of temperature, pressure and humidity across the front? Within air mass, they are similar, but across the front, they should be, hence the gradient will also be high. Because if the rate is changing fast, then the gradient will be high. Do we understand? Okay, so what will happen exactly at the front? At the front, because the gradient is high, you might have winds, but that is like a wind curtain. ठीक है, air curtain. आपने air curtains देखे? Where have you felt? बताओ. Where? Very good. At the mall. When you enter a mall, there is this glass thing, and the moment you enter, you might have felt, जैसे ही आप अंदर घुसते हो बहुत तेज हवा ऊपर से आती है, as if someone has put that fan on, कि आ रहे हैं तो थोड़ा हवा दे दो. वो आपके लिए हवा नहीं है. That's an air curtain. What is an air curtain? Air curtain is a high speed wind blowing in a region which separates the air on the two sides. So it will not allow the air on the two sides to cross that high speed wind. So that acts as a air curtain, so that the hot wind from outside will not enter into the cold mall region. नहीं तो वो mall का room भी गर्म हो जाएगा, because the door opens very often. So there they have this air curtain. Do you understand? So similar air curtain is naturally created at fronts. Why? Because the gradient is high. So there is so high speed wind moving in that region that it does not allow the air on the two sides to mix up. Is this clear? आ रहा है समझ में? ठीक है. So can we go beyond this? Right? So now types of front. Types of front. Types of front. So how many types of front do we have? We'll see. So that is something that we need to one by one understand. Now let me draw the 60-degree line as it is, and one side I draw 90-degree and the other side I draw 30 degrees. And please tell me, what have you learned in terms of winds moving in this region? 0, 30, 90, 60 and 30 degree. For example, between 90-degree latitude and 60-degree latitude, which winds blow? Huh? On the surface of the earth, which winds are blowing? Polar easterly is blowing in a what direction? ऐसा है ना, something like this. And in the 60 to 30 degrees, westerly, something like this. ऐसा है. So let me slightly modify and draw. So this polar easterly, I am drawing somewhat like ऐसा. Can I broadly draw it like this? I've just removed that north-south wala orientation, and along that front, because at 60 degree we have a front. Now, which front is there between at 60 degree? Separating which air masses? Polar and 60 degree. Polar and copy में देखो, मेरे को देख के नहीं बोलना है. At 60 degree, which front do we have? Separating the polar and Arctic. Polar and Arctic. ठीक है? So there we have the, so this is a front, right? And if this is a front, on one side of the front, and obviously this is a cold air mass and this is a warm air mass relatively. So the front has to be relatively okay, right? Let me not say very strong, let me not say very weak. So it's a decent front. If it's a decent front, air will not cross it. So the air on the this side, pole side, will be moving somewhat west to east, sorry, east to west, and the air between 30 and 60 will somewhat move west to east. Do we agree? तो यहाँ पे wind ऐसा move कर रहा है, and in between what do I have? That black line has. That black line will start behaving like a front. यहाँ पे okay, this line will behave like a front. So this is what the first front is. And will the two airs push into each other, or will they just go parallel and opposite? They will just tend to go parallel opposite, go up to this and then tend to rise up and create their Hadley and the Ferrel and polar cell. Okay, so they will just keep moving parallel. So if they are moving parallel, are they trying to push into each other? Is this westerly pushing this way? Is the easterly pushing? So will the front be pushed in any direction? So if it is not being pushed in any direction, will it move or will it remain stationary? And hence we should call it as stationary front. That's the first front. Okay, so it is called as a stationary front. That's the first type of front. Why do we call it as stationary? Because it does not move. Why doesn't it move? Because the air masses on the two sides do not push it. Okay, there is nothing because of which they are being pushed. Okay, so this kind of front we call as, yes, just coming to you. This kind of a front is called as stationary front. तो लिख लीजिए पहले थोड़ा. स्टेशनरी फ्रंट. हाँ जी बताइए. Air, there will be, that's okay, but that will not be able to push. Sorry. See, suppose there is a wall and let us say wind is blowing on one side, on the other side. So the air can create friction on the wall, but will it push the wall? It's so hard. There's nothing so hard like a wall there. That's what you're saying, right? But still, because both the air on both the sides is pushing almost equally. Okay, so if you push something, let us say if someone is standing and you push from one side and the other side there is no equal force, then the object can move. But if there is almost similar equal force on both the sides, it won't move anywhere. Yes. they will not be when you are seeing the whole latitude, but when you see 60 degree, there they will tend to be relatively more parallel because they will just come and they will tend to rise and create their cells. क्योंकि वो तो सेल बनाना है, वहां पे प्रेशर बेल्ट है ना, आप प्रेशर बेल्ट भूल रहे हो, वहां प्रेशर बेल्ट भी तो है. विच प्रेशर बेल्ट? सब पोलर लो प्रेशर बेल्ट. ठीक है, तो उसका भी तो इफेक्ट होगा ना. ओके, इज दिस ऑल राइट? क्लियर? So do we understand the stationary front? Is it clear? Similarly, you will have a stationary front between this and this. यहाँ पे भी एक 30 डिग्री पे भी stationary front होगा. So this one is called as polar front. This one is called as subtropical front. यहाँ पे भी between the which two air masses? At 30 degree between which two air masses? Polar and tropical air mass. Right? So there will be a front there also. We call it as subtropical front. ठीक है, so the name is this, the name of this front is polar front, the name of this front will be subtropical front. ठीक है, and right now we are understanding that both of them are stationary fronts. Why are they stationary? Because winds are just going past them and not pushing them in any direction. Right, so just once you have written, drawn this much, and let me also so this one is a subtropical front, and this one is polar front, subtropical front, and both of them are generally, initially they would be a stationary front. Both of them would generally be stationary. So once you have drawn this much, then we have to write what is the stationary front. Okay, so what is the stationary front? You have to write stationary front is created when the air masses on the two sides of the front, air mass on the two sides of the front, such as polar front or subtropical front, do not push the front in any given direction. Do not push the front in any given direction. Okay, and hence the front does not move much. Alright, so this is a stationary front. Now let us try to understand next. Once stationary front is done, which are the other types of fronts? So to understand the other type of fronts, I would take you to a diagram which we have earlier understood. Okay, so if in this diagram, ये वाला diagram में, if I ask you that can you see the polar front? कुछ polar front दिख रहा है? Region दिख रहा है? Region, it's not drawn, but can you see that region somewhere around 60 degree? This is the region where you have the polar front. Everyone agrees. And this side you have the Arctic air mass, and that side you will have the ये कंफ्यूजन आप लोग के दिमाग में अभी भी है, धीरे धीरे सेट हो जाएगा. Arctic and polar air masses. Is this okay? So on the two side you have this, and in between you have the front. So in this region you can say there is a front. Everyone agrees, and that is the subpolar low pressure belt also. And there you have this. So in this region, in the upper atmosphere below tropopause, क्या है हमारे पास? In the upper atmosphere below tropopause, what is blowing? Jet stream. कौन सा jet stream? Polar. पोलर नाइट जेट स्ट्रीम 60 डिग्री पे है ना. एक बार कॉपी में चेक करो. कौन सा जेट स्ट्रीम? कोलर, फ्रंटल जेट स्ट्रीम या नाइट जेट स्ट्रीम? पक्का? अच्छा, मैं जब भी कॉपी में चेक करो बोलूं तो आंसर चेंज कर देना है, ऐसा है ना? सर बोले कॉपी में चेक करो, आंसर चेंज कर दो, कोई बात नहीं. फिर मैं बोलूं कॉपी में चेक करो तो फिर एक और चेंज करके सर सब ट्रॉपिकल जेट स्ट्रीम, कोई बात नहीं, कुछ भी बोलो सर. हाँ पक्का है? पोलर frontal jet stream. Very good. So in this region you have the polar frontal jet stream in the upper atmosphere. Is this clear to everyone? ठीक है. So I can draw in the diagram. ये वाला डायग्राम में I can draw, let us say in I don't know क्या color, चलो white color use, लेकिन white I'm not sure whether it will be visible. This one, so ठीक है ऐसा. So I hope everyone agrees that in the upper atmosphere we'll have a jet stream like this. Everyone agrees? पक्का? सर ये ऐसा wave के जैसा क्यों बना है? Because jet streams wave. हाँ नॉर्थ साउथ वेव करता है ना, हमने पढ़ा था. तो जेट स्ट्रीम डू वेव, दैट्स परफेक्टली फाइन. सो देयर इज अ जेट स्ट्रीम लाइक दिस. सो ऑन द सरफेस यू हैव द फ्रंट एंड इन द अपर एटमॉस्फेयर यू हैव. नाउ ऑल ऑफ यू नीड टू फोकस, अदरवाइज यू विल मिस दिस. ठीक है? सो प्लीज बी हियर फॉर द नेक्स्ट 10-15 मिनट्स, राइट? सो आई विल रिपीट. ऑन द सरफेस यू हैव कौन सा फ्रंट? Stationary front, okay, and on the two side you have air masses, and in the upper atmosphere you have jet stream, and the jet stream is moving wave like, you can see. So if I ask you that in which case is the jet stream moving clockwise and which case the jet stream is moving anti-clockwise? A is moving. Everyone agrees? क्योंकि अब इसका आउटकम भी आप ही को मुझे बताना है. So in case of A it is moving and B it is moving. So in the northern hemisphere if you have a clockwise movement, what do you call it? आपने कॉपी में लिखा है clockwise movement anticyclonic, which means what pressure? High pressure. So at this region in the upper atmosphere what pressure should I experience? Created thermally or mechanically? This is thermal or mechanical? Mechanical, due to the jet stream motion. So the jet stream motion in the upper atmosphere will create a mechanical high pressure, and if it is mechanical high pressure here on the surface it will be on the front surface. वहां पे कैसा pressure होगा? Low pressure. Do we agree? And at location B, upper atmosphere, what is the movement? Anti-clockwise, hence cyclonic. So upper atmosphere what pressure? And surface? पक्का? Okay. So now I remove the jet stream. उसकी मुझे जरूरत नहीं है. Okay, and give me the pressure on the surface at location 1 and location 2. Location 1 surface pressure, low pressure. So I can say at the surface I have a low pressure here, and at another place I have high pressure on the surface on the front. Is this okay? Agreed? Pakka? So high pressure creates on the surface, high pressure will create what type of phenomena? Cyclonic, anticyclonic? On the surface. Anticyclonic, and anticyclonic is the phenomena that we study or we generally neglect? Neglect. तो इसमें से क्या मिटा दें? Very good. सब कुछ आप ही बताओगे. ठीक है, and where will we focus? Low pressure. That's it. So let us come to this low pressure. Clear? आया समझ में? So why did I leave everything else? Hopefully you understand, and we only focus on understanding this low pressure created over the front on the surface, and this is mechanical or thermal? Mechanically created low pressure. ठीक है? So on the front, when we have a mechanically created low pressure, you might ask me, sir, why is that low pressure created? Now do you know the answer? Why mechanically a low pressure is created? Why? Upper atmosphere jet streams are creating it. Is this okay? So once they create a low pressure like this, now let me redraw this diagram once more. Okay? And I'll try to simplify and draw. So let us say this is the stationary front, and on the stationary front now you also have a low pressure. So if I have a low pressure on the stationary front in the northern hemisphere, and on the two sides I have the winds, कौन कौन सा wind था? ये वाला wind ऐसा? Right? Don't draw the wind right now with me because I will modify it. And this wala wind is like this. So if I have a low pressure, then here the wind will start, the whole thing will start moving anti-clockwise. So if this is moving anti-clockwise, how should the westerly and polar easterly behave? Rather than moving parallel, now they should start bending and circling. Yes or no? Spiraling inward anti-clockwise. So should I spiral them inward anti-clockwise? Okay. So that's why I said please don't draw them. So this red one, the blue wind will start moving like this, aisa, and the other red one will start moving. Do we agree? Everyone? Yes or no? मतलब थोड़ा बता दो तो मुझे भी आसानी रहेगा यार. Is it? है ना? Manageable? बहुत ज़्यादा मुश्किल तो नहीं हो रहा है. Now tell me that westerly, and what are the directions here? ये कौन सा direction है ऐसा? I hope the directions are also clear to all of you in this diagram. We are seeing from the space. So this is east, west, north and south. This is the direction. So the westerly, is it pushing the front somewhere? Where? On which side? East or west of the low pressure? Which side of the low pressure is the westerly pushing the front? Eastern side. It is trying to push the front, right? And it is trying to push it which way? Into the colder air mass. Can you see this? It is trying to push it into the colder air mass. What is the air masses here? Warm and cold, वो भी लिख दें. This is cold. This one is warm. So it is trying to push the front into cold air mass. Can you see? And the polar easterly, what is that trying to do? Is it trying to push which side of the low pressure? West side of the low pressure. And into which air mass? Into the warm air mass. दिख रहा है? So now will the front remain stationary or will it be moving now? It will start moving. The stationary front, which was earlier not moving, will now start to move. Why? Because now the winds are pushing into each other. आ रहा है समझ में? ठीक है. So when they start moving, where the warm air mass is pushing, we call that front as warm. उसको कौन सा front बोलेंगे? Where the warm air mass is pushing, we call that front as warm front. This one. So this one we start calling as warm front. Why? Because the warm air mass is pushing. And the other front, where the cold air mass is pushing, that we start calling as, ये वाला is called as cold front. Why? Because the cold air mass is pushing. Is this okay? And when you go beyond this, let us say if you go further beyond this region, इन सबके आगे चले जाएंगे, on westward and eastward, suppose ये diagram इतना छोटा कर दिया, and let us say you go further beyond. If you go beyond them, is there any push? Are there more low pressure and high pressure? If we generally do not talk of them, let us say, let us say we are just focusing on one right now, right? So maybe another high pressure is slightly far away. Okay, so in between region, will I have a low pressure will I have a front? Matlab, will I have a warm front or cold front? For example, this part. No, so that will remain as a stationary front, and this one will also remain as stationary front. Maybe beyond them, you might again have a whatever pressure, high or low, and right, but this much part will remain stationary front, and this much part will become what fronts? Warm fronts. And why? Because they are moving fronts. Okay, so one is stationary front, second is moving front. Moving front are of two types, warm front and cold front. And why are they warm and cold? Hopefully you understand. आ रहा है समझ में? Any major doubt? Major doubt? None? तो डायग्राम बना लीजिए, फिर आगे लिखते हैं. No, it is not breaking. It is sections. Sections are behaving differently, but it will not break into something. Break मतलब गैप होना चाहिए, तो एक गैप नहीं हुआ इनमें. Every section is behaving differently. ठीक है? Yes. हाँ. Yes, obviously, alternate will form. So it is something like, ऐसा है. मान लो ऐसा करके, you have one low pressure somewhere here, ऐसा, and maybe another high pressure somewhere far. Okay, so in between region might not have much pressure. Beyond that, you might have again another high pressure, another low pressure. That's pretty much possible. Okay, drawn. ये जेट स्ट्रीम हटा दें इसमें से, उसका जरूरत नहीं है. Okay, once you have drawn this, then we have to write. Everyone drawn? Very good. Should we write now? लिख लें? Yeah. So let us write down the upper atmospheric jet streams. And do we have a similar front over subtropical, similar jet stream over subtropical front also? वहां पे भी कोई jet stream है? कौन सा? नाम चाहिए मुझे. Subtropical jet stream का नाम front. Subtropical पूरा नाम चाहिए. Subtropical कॉपी में चेक करके बताइए. Subtropical westerly jet stream. वेस्टर्ली जेट स्ट्रीम नहीं लिखा है हमने लास्ट से, तो लिख लो यार. अगर नहीं लिखा है तो चलो, ये मेरा मिस्टेक है, अच्छा हुआ. ठीक है, द फुल नेम इज सब ट्रॉपिकल वेस्टर्ली जेट स्ट्रीम. एंड ट्रॉपिकल वाले का क्या नाम है? ट्रॉपिकल ईस्टर्ली जेट स्ट्रीम. वो दूसरा है. दिस इज सब ट्रॉपिकल वेस्टर्ली जेट स्ट्रीम. प्लीज डू राइट दैट नेम कंप्लीटली. सब ट्रॉपिकल वेस्टर्ली जेट स्ट्रीम. ठीक है, सो वंस यू हैव रिटन दैट नेम, now come back to what we were writing. हाँ जी बताइए. ही सबट्रॉपिकल वेस्टर्ली जेट स्ट्रीम, उसका पूरा नाम है सबट्रॉपिकल वेस्टर्ली जेट स्ट्रीम. ठीक है, नाउ वो थोड़ा पढ़ दो. क्या बोला मैंने लास्ट टाइम? थोड़ा मोड़ा ही बोला है. हाँ, in the upper atmosphere, in the upper atmosphere, over the fronts, in the upper atmosphere, over the fronts, within bracket polar or subtropical fronts, over the fronts, within bracket polar or subtropical front, bracket closed, we have jet streams. We have jet streams within bracket polar front jet stream, polar front jet stream and subtropical westerly jet stream respectively. Within bracket polar front jet stream and subtropical westerly jet stream respectively. Bracket closed. full stop. These, due to their north-south wave-like motion, these due to their north-south wave-like motion, due to their north-south wave-like motion, create high or low pressure conditions in the upper atmosphere, high or low pressure conditions in the upper atmosphere, due to clockwise anti-clockwise waving, due to clockwise anti-clockwise waving respectively, clockwise anti-clockwise waving respectively, full stop. And this creates a corresponding opposite pressure condition on the surface, opposite pressure condition on the surface over the fronts, over the stationary fronts, pressure condition on the surface over the stationary front, opposite pressure condition over the surface on the stationary front. Okay, so whatever pressure is there in the upper atmosphere, opposite of that will happen on the surface on the stationary front. Is this okay? Yeah. यार ये मेरे लिए बड़ा मुश्किल काम होता है. So let me help, yeah, can you read that last point? This, give me part wise so that I can, repeat it. This creates
a corresponding opposite pressure condition
this creates a corresponding opposite pressure condition on the surface over the stationary front. Is that okay? ठीक है. This is the problem of not dictating from any paper, because I dictate whatever I make you understand on the basis of that. ठीक है, तो मेरे पास ना वो written dictation होता नहीं है, and I find it really boring. I have tried many times. I do bring those written kind of dictation that I find so boring to dictate. वो खड़े होके बस पढ़ते रहो ऐसा करके. ठीक है, तो मुझे मजा नहीं आता है वैसा पढ़ाने में. So I'm so sorry, I can't help it, and I hope all of you understand. And चल जाएगा ना इतना, मतलब थोड़ा मोड़ा तो चलता है ना, कॉम्प्रोमाइज करना पड़ता है. इतना कॉम्प्रोमाइज चलेगा ना? हाँ, डिक्टेशन के बिना, या चाहिए पीडीएफ मतलब पक्का आता है आप लोगों को, समझ में आता है ना क्लास में? बस मुझे इतने से मतलब है. बाकी अगर मान लो कुछ मिस कभी हो भी जाए ना, तो यू ऑलवेज हैव दैट वीडियो ऑप्शन. आजकल तो आप लोगों के पास है, कहीं ज्यादा मिस हो तो थोड़ा मोड़ा पीछे जा करके देख सकते हैं. ठीक है. सो now we have created those pressure conditions on the surface. Clear? So once you have the pressure condition, now let me talk in terms of those pressure conditions. So should we write further? लिख लें आगे. Now the high pressure conditions give us anticyclonic fair weather conditions. The high pressure conditions give us anticyclonic fair weather conditions. Anticyclonic fair weather conditions, which we do not discuss, which we don't discuss further. Whereas the low pressure condition, whereas the low pressure condition over the stationary front, low pressure condition over the stationary front creates a mechanical condition causing spiraling anticlockwise, mechanical condition causing spiraling anticlockwise and inward, as shown in figure A, and you call this as figure A. इस वाला फिगर का नाम रख दो, फिगर ए, एज शोन इन फिगर ए, दिस वन. एंटी क्लॉकवाइज स्पाइरलिंग एज शोन इन फिगर ए. Okay, right? So, the anti-clockwise spiraling, causes the warm air to push on the eastern side of the low pressure, causes the warm air to push on the eastern side of the low pressure, and hence causing the stationary front to move towards cold air mass, this one, to move towards cold air mass. ठीक है? This moving front is known as warm front. Where it is being pushed from by the warm air. This moving front is known as warm front, where it is being pushed by warm air mass. Moving front is known as warm front, where it is being pushed by warm air mass. So this part you call as warm front, and I hope everyone has drawn. ठीक है? Warm front, where it is being pushed by warm air mass. So this part. This is your warm front and this is the moving front. Why? Because it is being pushed by warm air. Right? Why is it pushing? Because of the spiraling thing. All that. ठीक है? On the, now write down next paragraph. On the west of the low pressure, created, west part of low pressure created, the cold air pushes the stationary front into the warm air mass, and this moving front is known as cold front. Because it is being pushed by cold air mass. Because it is being pushed by cold air mass. Is this okay? ठीक है? Right? So you have everything in the figure and this way. So should we go beyond this? So you understand how the cold and warm fronts are created? Underline those words, warm front and cold front, and earlier where you have written stationary front, underline that also. ये तीन टाइप का फ्रंट हो गया हमारा. कौन कौन सा? स्टेशनरी फ्रंट, वार्म फ्रंट, कोल्ड फ्रंट, तीनों अंडरलाइन कर लीजिए. ठीक है? ओके, गुड. नाउ लेट अस गो बियॉन्ड दिस. सो शुड वी आगे बढ़े थोड़ा सा? हाँ जी बताइए. देयर विल बी फ्रंटल साइक्लोन्स. आते हैं वहां तक. पहले प्रेसिपिटेशन कर लें, पहले साइक्लोन बना लें. अभी तो साइक्लोन में नहीं बनाया, अभी तो फ्रंट तक ही पहुंचे ना. ठीक है, तो एक बार जब साइक्लोन बना लेंगे तो हमें प्रेसिपिटेशन खुद समझ में आएगा. आप ही मुझे बताओगे, रादर मेरा ये सब मेरे को आप लोगों से पूछना होता है. ठीक है, आई शुड बी आस्किंग कहाँ पे स्ट्रॉन्ग रेन है, कहाँ वीक रेन है. दैट यू विल अंडरस्टैंड ऑन द बेसिस ऑफ टाइप ऑफ क्लाउड. दैट यू विल अंडरस्टैंड ऑन द बेसिस ऑफ मूवमेंट. तो अभी हम धीरे धीरे मूवमेंट समझ रहे हैं. जब पूरा मूवमेंट समझ जाओगे तो क्लाउड समझ में आएगा. वंस यू अंडरस्टैंड क्लाउड देन यू विल अंडरस्टैंड कौन सा प्रेसिपिटेशन होने वाला है. इज दैट ओके? ठीक है, और कोई डाउट? आई विल कम टू यू. एनी अदर डाउट? नन? हाँ जी बताइए. सर सिमिलर फिनोमेना, सर विल देयर बी अ सिमिलर फिनोमेना एट 30 डिग्री लैटिट्यूड आल्सो? हाँ, so that's what you're asking me ना. Yes, at 30 degree latitude. Yes, subtropics. Yes. सी हाँ देखो ये ना ओवरलैप्स हैं नेचर के अंदर. देयर इज लॉट ऑफ ओवरलैप हैपनिंग, राइट. सो वन पार्ट क्रिएट वन टाइप ऑफ प्रेशर, another phenomena will come that will create a differing pressure. Because of that differing pressure a unique condition is created. That unique condition will give you a unique weather phenomena. ठीक है, तो नॉर्मली वहां पे हमेशा साइक्लोन नहीं रहता है, बट जब ये यूनिक कंडीशन हो जाएगा कि वहां पे तो सब ट्रॉपिकल हाई प्रेशर था, दैट्स व्हाट यू आर सेइंग, या यहाँ पे सब पोलर लो प्रेशर था, राइट. एंड ऑल ऑफ अ सडन अ मैकेनिकल फर्दर कंडीशन इज क्रिएटेड ड्यू टू जेट स्ट्रीम एंड ऑल दीज विंड्स. सो दैट विल क्रिएट अ लोकलाइज्ड यूनिक कंडीशन, है ना, ओवरलैपिंग ऑफ हाई प्रेशर एंड लो प्रेशर. नाउ वॉट एवर विल प्रिवेल on that basis the outcome of that region will be. So sometimes you might get cyclone, sometimes you might get a weak cyclone, sometimes you might not get a cyclone. ठीक है, it depends completely on how that overlapping, right, at that given moment prevails. Yes, the front is like vertical. So जैसा आप इस रूम में बैठे हैं तो just imagine कि that you are sitting in the tropopause. So this is this is tropopause, this is surface, you are in it, and the front is like this. That is something that you learned earlier also. वो तो होता ही है. फ्रंट के लो प्रेशर वाली साइड पे, हाँ सरफेस पे लो प्रेशर है. हाँ तो ये तो सरफेस पे हो रहा है. एटमॉस्फेयर नहीं, अपर एटमॉस्फेयर. दैट्स व्हाट यू मीन. अपर एटमॉस्फेयर में हाई प्रेशर है, सरफेस पे लो है, तो ऊपर क्या होगा. अच्छा, सरफेस पे लो है तो एक और सरफेस पे उधर हाई है, तो उसके ऊपर वाला लो, उस पे अगर ये होगा भी, सपोज जस्ट इमेजिन, मान लो उस पे अगर होगा भी, तो वहां तो विंड मूवमेंट का डायरेक्शन उल्टा है ना. वर्टिकल आउट वहां नीचे को आता है ना. तो वो कंडीशन अलग है. और अपर एटमॉस्फेयर के बारे में हम ज्यादा घुसते नहीं, क्योंकि वहां जेट स्ट्रीम भी है. सरफेस पे तो सिर्फ वेस्टर्ली ईस्टर्ली से काम चल जाता है. ठीक है, तो वहां फिनोमेना और कॉम्प्लिकेट हो जाता है. उसको पढ़ने के लिए ज्योग्राफी ऑप्शनल पढ़ना पड़ेगा, जरूरत नहीं है. ठीक है, तो यूपीएससी के साथ ना बहुत मजेदार चीज है. यू नो, पहले हमें वो स्कॉलर बनाने का कोशिश करता है, क्योंकि हमारे अंदर वो विलिंगनेस होती है सब कुछ जान लें. लेकिन जैसे ही पता लगता है सिलेबस के बाहर है, तो हम क्या बोलते हैं, छोड़ो यार, ये पढ़ने थोड़ी आए थे. ठीक है, एंड दिस इज वेरी नेसेसरी, क्योंकि जो भी ये भूल जाता है और वो उसका बोलता है नहीं मैं तो इसका एक्सपर्ट बन के रहूंगा, बिकॉज आई हैव टू प्रूव टू माई फ्रेंड्स. वो बेचारा पूरा लाइफ प्रूव टू फ्रेंड करता रहता है, क्योंकि आईएएस वो फ्रेंड बन जाता है. ठीक है, तो ये कोशिश करना है कि गोल क्लियर रखना है कि कहां तक जानना है. That is very very important. That's why on the, I don't know whether your people remember this. On the very first day I told you I'm not here to teach you geography, because I'm not a geography teacher. ठीक है, no matter how well you understand geography in this class or whether you understand or not, I'm not a geography teacher. मेरा एक सिंपल पर्पस है, क्या, ज्योग्राफी फॉर यूपीएससी एग्जाम. मेरे को उससे ज्यादा नहीं पढ़ाना आप लोग को. ठीक है, तो उसके आगे पूछना है तो बहुत सारा यूनिवर्सिटीज है दिल्ली में, वहाँ बहुत सारे प्रोफेसर बैठे हैं, वो सब ज्योग्राफी में पीएचडी है, उन लोग का जाके प्राण खाइए. ठीक है, हाँ जी बोलो. फिर से बोलिए. इन द जेट स्ट्रीम्स, इन कैन द जेट स्ट्रीम. अच्छा हाँ, कैन द जेट स्ट्रीम, कैन द जेट स्ट्रीम फ्लो अवे द प्रेशर. जेट स्ट्रीम तो अपर एटमॉस्फेयर में है ना, एंड सरफेस पे. अच्छा, मे बी योर क्वेश्चन इज सर व्हेन द जेट स्ट्रीम इज वेविंग, सो लेट अस से लो प्रेशर इज क्रिएटेड और अ हाई प्रेशर इज क्रिएटेड, हाउ फास्ट डज दैट वेव मूव, नॉट द विंड इन द वेव. एक हो गया विंड का मूव करना, और एक है वो वेव का मूव करना. द वेव डज नॉट मूव एज फास्ट एज द जेट स्ट्रीम. द वेव मूव्स वेरी ग्रेजुअल. In the wave, द विंड विल मूव फास्ट, ठीक है। लेकिन अगर आप वेव का मोशन देखोगे तो वेव का मोशन स्लो है। तो द जेट स्ट्रीम, द होल सिस्टम, सपोज दिस द वेव, this is the anti-clockwise, so the surface clockwise, that will also slowly move with it. Hence the whole system will move, it will move. That's where I have to take you, don't worry, right? But it will not move as fast as jet stream, ठीक है। और कोई सुनामी याद है ना? तो I told you in tsunami that the wave in the ocean moves at 800, but the water does not move at 800, ठीक है। तो ये वैसा ही है, विंड विल मूव एट 300 बट नॉट द वेव विल मूव एट 300, ठीक है। ओके, अभी आगे बढ़े। हाँ 37। एक काम करते हैं बिफोर, बिकॉज इट विल टेक टाइम, राइट? सो टेक योर ब्रेक, 15 मिनट का ब्रेक ले लो, उसके बाद मिलते हैं, देन वी स्टार्ट फ्रॉम हियर, ऑलराइट? एंड एवरी टाइम आई टेल यू पीपल कि यार इसके आगे नहीं जाना है, होपफुली यू डोंट माइंड इट, और अगर माइंड करते हो तो भी मेरा लॉस नहीं है, ठीक है। सो देयर इज अ डाउट, या सर ड्यू टू जेट स्ट्रीम्स आफ्टर एवरी इंटरवल मैकेनिकल लो हाई प्रेशर कंडीशन, interval mechanical low high pressure conditions will be created on the surface, but won't it interfere with the pressure belts? It will interfere, and that's why it will create these, you know, anticyclonic or cyclonic condition. Once you have cyclonic, subpolar low, cyclonic, so that is okay, but when you have subpolar and anticyclonic, you will have a fair weather condition, ठीक है? So does that answer, sir? Right. Okay. So, I guess this much is clear to all of you, right? Now, should we move beyond? Doubt है? हाँ बोलो. As we go higher in air mass, क्लास के बाद आना, ठीक है? पर्सनल डाउट है, why should I take? Because I've already answered for most of you. ठीक है, तो next, anything else? ये मैंने आंसर दिया है क्लास में, ठीक है? तो आप एक बार फिर से आइए, we'll discuss. Anything else? आ रहा है, आएगा भी, वी आर स्टिल टू डू, ठीक है? सो ओके, एनीथिंग रिलेटेड टू दिस पार्ट ऑफ द स्टोरी? इतना में कुछ कोई डाउट है? नहीं? आगे बढ़ जाएं? वेरी गुड. सो when we talk of these two fronts, so I hope please all of you, सबका सब फिर से फोकस करो, right, so that you get what we are going to discuss. So when we talk here in the warm front region, where the warm air is pushing the front into the cold air region, ठीक है? So I'll draw this part first for you, ठीक है? इसका देखते हैं how will this look like. Now right now what you are seeing is from the sky. We have seen that we are seeing a video, you know, something like seen from a height. Now let us try to see if you are standing somewhere in the southern part of this and seeing all this happening in front of you, ठीक है? So at the same height, so I'll draw that in terms of direction and all. So suppose this is the surface of the earth and this is tropopause, and please do draw along with me, and we are drawing for warm front, ठीक है? Warm front diagram. So tropopause, surface of earth, okay, and east-west. This is east-west. So east and west. So you are standing somewhere in south and trying to see what is happening in that east-west direction. ठीक है, मान लो इंडिया में खड़ा होकर आप देख रहे हैं कि रशिया में क्या हो रहा है, वैसा. ठीक है. So and here the imagination has to be slightly big, right? I hope everyone understands, right? So in this, when the warm air will try to push, so ऐसा पहला एक front जैसा, let me make something like this. You will have a front, okay, and one side you will have warm air and the other side you will have cold air. Right, so this is the cold air mass. Cold, and the other side you have warm air mass, something like this. And the warm air mass is pushing into the cold, ऐसा. So the warm air mass is pushing like this. ठीक है? Alright, and I have deliberately drawn it slightly slopey, so I would expect you also to draw that way only. ऐसे थोड़ा slope के जैसा बनाएगा. Okay? ठीक है? Drawn? है ना? Now let us try to slightly discuss and then we go beyond. So basically what is happening is, we saw that the westerlies are pushing the front into the polar easterly wala region. So warm air is being pushed and something like this it will, and this is how it is being pushed. So the warm air is pushing this thing. Now just try to focus and give me an answer. When I talk between warm air mass and cold air mass, which one will be light and which one will be dense? Warm air mass will be light and the cold air mass will be dense. है ना? Simple सा logic है. Very good. And so when the light air is trying to push a denser air, something light is trying to push something dense. I generally give this example for you to make it easy for imagination. Let's say I have a very big bunch of cotton, loose cotton, रुई, right? Everyone understands रुई, cotton? तो ऐसा बहुत बड़ा bunch है रुई का. And then you have a very big bunch of cement mixed with water. ठीक है? And that cotton thing, you are trying to push that cement thing, because the cement part is dense and the cotton part is light. So suppose you are trying to push. So will it be easy first of all to push? No. Secondly, will the cement move too much due to the cotton? No. Right. So what will, if you go on pushing, what will finally happen? The cotton will start pressing against the cement and then it might start rolling over it. Okay? So same ways, imagine here, when the lighter is being pushed, is trying to push the denser, the lighter will first accumulate here, and because it will not be able to push the dense too much, so it will tend to roll over the, right, or move up the denser air. Is this okay? And while it will go up, it might just slightly bend this thing, because this will not lift up. Dense thing does not lift up, only the light will lift up. So the light will tend to gradually keep shifting upward and it might go up the slope. Okay, so basically it will create the front, or it will bend the front, which was earlier supposed to be something like this. This front was earlier supposed to be somewhat like aisa. Okay, something like this. But just by pushing, the warm air has slightly bent it so that it can roll over. Do we get it? So aisa, what will happen? Basically, the warm air will not be able to push the whole cold air mass easily, so it will tend to bend it and move over it. It's not that it will not move it, it will move it, but it will not easily move it. So part of it will go up and part of it will push. आ रहा है समझ में? ठीक है. Now, as this warm air will start going up, ये कौन सा सिनेरियो हो गया? You had a low pressure on the surface, mechanically created, and now the warm air has also started rising, and this warm air is rising up convectionally, orographically, or over the front. Over the front. तो ये कौन सा rise है? Frontal rise. Do we get? आपने अभी पहले दो टाइप का rise पढ़ा था. Which were they? Convectional and orographic. This is the third type of rise. This is the orographic rise. Sorry, this is the frontal rise. Is this okay? So front formation, front bending and rising over the front. Warm air will tend to rise. Okay, clear? Okay. Now the next part. If this much is clear, as the warm air will rise, will it cool? Warm air, when it tends to rise, will it gradually cool? Will it condense? Cloud formation. So if it will form cloud, will it form vertical cloud or cloud at different levels? क्या लगता है? Is this vertical? Yeah, it is slopy. So on this, what type of cloud should I find? Vertical cloud such as cumulonimbus cloud or different height clouds such as कौन सा height था? सबसे lower? सबसे lower clouds. Stratus, then middle cloud, alto और सबसे ऊपर. That's it. So on this we get which type of clouds? Do you understand? At different height of the front, I will get clouds of different nature such as stratus, alto and cirrus. Yes or no? Are you clear hai? So do you understand this whole thing? Right? So now what all do I have at this front? Give me what all is happening. One, do I have a low pressure? Yes or no? Do I have spiraling inward? Anti-clockwise spiral था ना? Upper atmosphere में था तो उसका उल्टा ही तो बन रहा था. So do I have spiral inward? Do I have low pressure? Do I have rising winds? Do I have clouds? Will I get rain? सब कुछ हो रहा है. So this is cyclone. कौन सा cyclone? Frontal cyclone. ठीक है? So hence we call it as cyclonic also. Why? Because it is fulfilling all the conditions of cyclone. Which were the conditions of cyclone? Low pressure, anti-clockwise circulation, spiraling inward, rising wind, cloud formation, rain, सब कुछ ही है. So you call it as cyclonic. और कौन सा cyclone? Front का वजह से बन रहा है. So we call it as frontal cyclone. Which region is it formed in? Tropical or temperate? Tropical or temperate? Temperate. So कौन सा cyclone? Temperate cyclone. ठीक है? Mid latitude. So mid latitude cyclone. Extra tropical. So extra tropical cyclone. Are you son? So this is how we get warm front temperate cyclone. This is what? Which front? Warm front. ये warm front temperate cyclone है. Is this clear? Right? Now should I give you the other one also? वो भी साथ साथ कर लें, then we'll write, या अभी लिखना है? Tell me. अच्छा पहले आप मुझे रिवाइज कराओ मेरा रिविजन. वो भी तो जरूरी है, कहीं मैं ना भूल जाऊं. Okay. So give me. How does it start? I need all the cycles, all the steps in this. सबसे पहला what do you get? Upper atmosphere. वहां से start करो. You get a upper atmosphere jet stream. Which pressure condition in the upper atmosphere? So for that what circulation? Clockwise or anti-clockwise? Depends on hemisphere. So in northern hemisphere, clockwise. So will give us upper atmosphere, high pressure, hence anti. So on the surface, low pressure, hence cyclonic. देखो आपने शुरू में ही cyclonic बोल दिया. तो एक तो ये cyclonic हो गया because it was low pressure. But is it thermal or mechanical? Mechanical. Where is it formed? Over the front. है ना? On the front, stationary front. Now, on the stationary front, on the eastern side I get which air pushing which air? Warm air pushing cold air. Hence which front form? Warm front. Now, how does the warm front push or move? The warm lighter air pushes the denser air, hence bends and rises. So bending, rising. What type of clouds? Vertical clouds or relatively horizontal? Relatively horizontal. ठीक है? So and we have all the condition fulfilled. Hence warm front, cyclone. और rain कैसा होगा? Very intense or relatively less intense as compared to vertical cloud? Relatively less intense. That's it. समझ में आ गया आपको? ठीक है? So should we also do the cold front? वो भी साथ साथ कर लें. लास्ट में लिखेंगे आराम से, है ना? So Okay, any major doubt? कोई doubt? In, sorry? थोड़ा सा louder बेटा. You are confused? अच्छा, तभी तो डाउट पूछोगे ना. हाँ बोलो. कंफ्यूजन क्या है? अच्छा, लो प्रेशर हाई प्रेशर समझ में आता है. गिव मी ऑन द सरफेस हाउ कैन लो प्रेशर बी क्रिएटेड? मैकेनिकल एंड, डू यू अग्री? इतना पक्का क्लियर है? ऑन द सरफेस इफ आई हैव लो प्रेशर, अपर एटमॉस्फेयर आई विल हैव हाई प्रेशर. हाई प्रेशर कैन ऑल्सो बी क्रिएटेड मैकेनिकली. तो इफ द विंड इज मूविंग एंटी क्लॉकवाइज इट इज साइक्लोनिक. एंड साइक्लोनिक मतलब लो प्रेशर या हाई प्रेशर? लो प्रेशर. तो अगर ऊपर साइक्लोनिक विंड मूव कर रहा है एंटी क्लॉकवाइज तो इट विल क्रिएट लो प्रेशर, है ना. एंड इफ द विंड इज मूविंग एंटी साइक्लोनिक clockwise it will create upper atmosphere. So if in the upper atmosphere you have high pressure, what pressure should I get on the surface? Opposite ना, low pressure. यही डाउट था. नीचे एंटी साइक्लोनिक ऑब्वियसली. ठीक है, वो सिर्फ विंड कैसा मूव कर रहा है वो देखना है हमें. ठीक है, इफ एट वन प्लेस द विंड इज कन्वर्जिंग द अदर प्लेस इट हैज टू डाइवर्ज, क्योंकि विंड तो वही है ना. कन्वर्जिंग डाइवर्ज, कन्वर्जिंग डाइवर्ज. ठीक है, और साइक्लोनिक एंटी साइक्लोनिक वो अब कोरियोलिस फोर्स इफेक्ट है. ठीक है, साइक्लोनिक इट इज कन्वर्जिंग, एंटी साइक्लोनिक इट इज डाइवर्जिंग. ठीक है, थोड़ा रिवीजन करना है ये सब. ये सारा डाउट जो आ रहा है वो सिर्फ रिवीजन का वजह से आ रहा है आप सबको. ठीक है, रिवीजन नहीं है इसलिए आप लोग भूल जाते हैं, राइट. और हर क्लास में रिवाइज कराना मेरे लिए मुश्किल होगा, तो इसीलिए थोड़ा सा आप लोगों को भी रिवाइज करके आना है. यही ज्योग्राफी का सबसे बड़ा स्ट्रेंथ और वीकनेस दोनों है. स्ट्रेंथ इसलिए क्योंकि जिसने रिवाइज कर लिया और जिसको समझ में आने लग गया उसको आने लगता है, और जिसको नहीं आता दे कीप मिसिंग ऑल दोज थ्रेड्स एंड हेंस फिर वो ज्योग्राफी धीरे धीरे उनसे दूर जाता रहेगा, क्योंकि ना ये समझ में आएगा ना वो समझ में आएगा. डू यू गेट इट? सो देयरफॉर यू हैव टू रिवाइज regularly. Okay, that's the only thing. There is nothing else which can make you understand geography. Geography के अंदर if you think you come in one class and you understand that class and go and come after 3 class and understand that one class and go, वैसा हो नहीं पाएगा कभी भी. ठीक है, वो सिर्फ तभी हो सकता है जब क्लास में बस डिक्टेशन करो, लिखो, रटो, जाओ. Alright, so come back. Let us come to the third case. Sorry, third नहीं, कौन सा वाला? Cold front case. Should we? In all my classes, I get two type of students. You know, I have hardly come across third type. One, they like the class. Second, they dislike the class. ठीक है, I have hardly come across students who say नहीं ठीक था, average. Geography class कभी average नहीं होता, या तो like होता है या डिसलाइक. मतलब वो फेसबुक का वो पेज नहीं है कि स्क्रॉल करके निकल जाएगा, वहां रुकोगे ही रुकोगे, और या तो लाइक करोगे या डिसलाइक करोगे, ऐसा निकल नहीं पाओगे वहां से. ठीक है, तो आपको देखना है कि आपको क्या करना है. ओके, तो नाउ please see I am changing your orientation and hence the directions will also change. ठीक है, तो अभी थोड़ा ध्यान से देखना what is happening. Okay, so tropo pause. Now you are not standing at the same place where you were standing earlier. ठीक है, so please see कि ये कैसा आपको किस orientation से ऐसा दिख रहा होगा. So Okay, and I hope you all of you understand which is cold and warm. So this is cold, this is warm, and the cold air is pushing the warm air, ऐसा, ठीक है? All right? And surface of earth, वो नीचे वाला part is surface of earth, hopefully. All right? Now once done, then we'll talk further. Done? Okay, now tell me, in this which air mass is pushing which air mass? Hence, dense or light? What is pushing what? The dense is pushing the light. So if the dense is pushing the light, will it be easy to move? Yes, it will be easy to move. So the whole warm air mass will move on. Is this clear? And hence, because if this is pushing this way, can the cold air mass go over the warm air mass? हो सकता है? नहीं होगा, क्योंकि denser can not go over the lighter. So जैसा bending earlier was happening, that kind of thing you will not find here. So this will just go on pushing and this will easily go on moving forward. Is this okay? Therefore, or hence, this front will not bend. It will remain straight. Why? Because the force is coming like this and the whole thing is easily moving forward. Clear? So the whole front remains straight, almost close to straight, and it will keep moving in a west to east direction. Clear? And secondly, I hope you can understand that as it will push this warm air, in this region there will be some warm air accumulation. If you try to push something, वहाँ पे accumulation हो जाता है ना? So that warm air accumulation will happen and here some warm air will tend to rise. ऐसा? Warm air will move forward as well as it will tend to rise on that margin where it is being pushed. Easy है? So if now again you get what? Along the front, warm air is rising and this time it is rising relatively more vertically, right? So what type of cloud formation should I expect here? सबसे बड़ा cloud formation हमने कौन सा vertical cloud देखा था? Cumulonimbus. So in this case we might get relative cumulonimbus cloud formation. Yes or no? अरे cloud difference कैसा है दोनों में? And this is which front? Cold front or warm front? Cold front. So on the cold front, the front remains relatively vertical and the warm air rises relatively vertically and hence it leads to formation of relatively vertical clouds such as cumulonimbus cloud. And if it is cumulonimbus cloud, precipitation should be higher or denser. आपका जो पहले वाला question था, ठीक है? So do we get it? Right? So this will give us denser precipitation or heavier precipitation. Clear? So क्लाउड बना लीजिए, वो जो विंड डायरेक्शन है, और उसके बाद फिर लेट अस राइट. एंड प्लीज डू राइट. यहाँ पे ना वो पिछला वाला में क्लाउड्स में लिख लेना, राइट दोज डिफरेंट लेवल्स, स्ट्रैटस, ऑल्टो, सिरस इन द प्रीवियस डायग्राम एंड इन दिस वन राइट क्यूमुलो निम्बस. वो लिख लीजिए. Okay, once drawn and everything is there, and इस वाले का cold front diagram नाम रख देंगे. I hope everyone understands. और दूसरा वाला warm front diagram. So we'll talk like that, warm front and cold front diagrams. ठीक है? So should we write? Should we write now? Okay, so let's start with the warm front wala. Right, so you can write, as we see in the warm front diagram, As we see in the warm front diagram, the lighter warm air pushes the denser cold air. Lighter warm air pushes the denser cold air. And hence finds it relatively difficult to push the front. And hence finds it relatively difficult to push the cold air mass. You write this way. Finds it relatively difficult to push the cold air mass. Therefore, the warm front bends over the cold air mass. The warm front bends over the cold air mass, and the warm air starts to rise. Warm air starts to rise over the inclined warm front. Warm air starts to rise over the inclined warm front, causing the formation of clouds at different heights. Formation of clouds at different heights, such as stratus, alto, and cirrus. Stratus, alto, and cirrus. Okay. These clouds give relatively less precipitation. Relatively less precipitation as compared to cold front. Full stop. Hence, as compared to cold front. Hence, in the case of warm front, we find finally cyclonic spiraling inward winds. Cyclonic spiraling inward winds. Rising warm air. Spiraling cyclonic inward winds, comma, rising warm air, cloud formation and precipitation, and hence we call it as warm front cyclone. Hence we call it as warm front cyclone. Okay, so this becomes a warm front cyclone. Underline that, warm front cyclone. Now, come to the next diagram. Next paragraph and next diagram. In the cold front diagram, we find that the cold air mass pushes the warm air mass, the cold denser air mass pushes the warm lighter air mass easily. hence the front does not bend, hence the cold front does not bend, cold front does not bend, and remain relatively vertical, and remain relatively vertical. Which term? The warm air accumulated around the cold front, warm air accumulated around the cold front due to pushing, accumulated around the cold front due to pushing, tends to rise, along the vertical front, creating relatively vertical clouds along the vertical front, creating relatively vertical clouds within bracket cumulonimbus, vertical clouds within bracket cumulonimbus, and causing relatively heavier rains. Cumulonimbus and causing relatively heavier rains. Full stop. Here also we find low pressure, comma, cyclonic inward spiraling winds, low pressure, comma, cyclonic inward spiraling winds, comma, rising warm air, clouds and rain, rising warm air, clouds and rain, and hence it is known as, or called as rising wind, cloud and rain, and hence it is known as cold front cyclone. Cold front cyclone. So it is something like this. You can see one side you have the warm front cyclone, the other side relatively cold front cyclone. Is this okay? And this is how the rising of warm air happens in fronts. वो front वाला diagram है. I hope you remember where we were talking of the processes causing precipitation. उसमें हमने पढ़ा था ना. So this is that fronts related precipitation, lifting along fronts. Okay. उसका ऊपर था एक ये orographic और एक convectional. So तीन टाइप का राइजिंग हमें समझ में आ गया. अब एक बचा है ट्रॉपिकल साइक्लोन, वो हम बाद में करेंगे. ठीक है. सो इज दिस मच अंडरस्टूड? एनी मेजर डाउट? हाँ जी. इंक्लिनेशन हम नहीं हटा सकते ना, वो तो नेचुरल फिनोमेना है. बिकॉज द वार्म एयर इज ट्राइंग टू पुश समथिंग डेंसर, सो इट इज नॉट एबल टू पुश इट. ठीक है. तो अगर आप पुश नहीं कर पा रहे हैं और फोर्स लगता जाएगा तो यू विल रोल ओवर इट, तो अपने आप ही इंक्लाइन सरफेस हो गया. ठीक है. ओके, क्लियर है? सो शुड वी गो बियॉन्ड दिस? नाउ व्हाट इज द जनरल डायरेक्शन ऑफ मूवमेंट ऑफ ऑल दिस? क्या लगता है? वेस्ट टू ईस्ट, right? Why? Because mostly it is happening in the westerly wala region. One. Secondly, the jet stream is also moving west to east, and the waves of the jet stream will also move west to east. So a whole system will move west to east. So we have to write the cold front and the warm front both move in a general. The cold front and the warm front both move in a general west to east direction. Cold front and warm front both move in a general west to east direction, driven by the westerlies and the jet streams, west to east direction driven by the westerlies and the jet streams. Okay, good. Now let us come back to our front. So let us again look at the diagram from sky. फिर से ऊपर से देखते हैं ऐसा. So same north south, east west seen from the sky, and suppose this is your stationary front, and in between you have the cold front and the warm front. ऐसा यही पढ़ा है ना अभी तक. And the whole thing is moving in a west to east direction. Now if I ask you which of the two fronts will move easily and which of the two fronts will find it relatively difficult to move, ये आपने लिखा है. Warm front will move easy or difficult? Warm front, where the warm air was pushing the denser cold air. Difficult. So the warm front will move difficult and the cold front will move easy. One. Second, which front is eastern one and which front is western one in general? अभी तक आपने जो पढ़ा है, which one is on the east side and which one is on the west side? Warm front is on the east side and the cold front is on the west side. Do we agree? And why? You understand why? वो सब logics हम देख चुके हैं. ठीक है? So you can say that this front will move slow and this one will move fast. Everyone agrees? And they are both moving in a west to east direction. Okay, so what is the general direction for all of them? The general direction is something like this, west to east. So over a period, if one is moving fast, the other is moving slow, what will happen? The slow one might, for example, reach here, aisa, and the cold one might come close. I am not drawing the remaining stationary. अभी उसका जरूरत नहीं है मुझे. Do we agree? है ना? वो जो cold one है वो उसका पास आ जाएगा. So warm one might have moved, but the cold one will move faster and catch up. Next, what will happen after this? Next step. Further, cold one will come further, while the warm one moves less. And ultimately, what can happen? Both of them tend to overlap. Imaginable? बहुत मुश्किल तो नहीं है. एंड इसके आगे पीछे क्या होगा? ईस्ट एंड वेस्ट ऑफ दिस स्टेशनरी फ्रंट. लास्ट में मैंने फिर से बना दिया. ठीक है. सो दिस इज स्टेशनरी फ्रंट, दिस इज ऑल्सो स्टेशनरी फ्रंट, एंड दैट्स वेयर द वार्म एंड कोल्ड हैव merged. Clear? So seen from above, do you understand this? How they are merging? These 4 steps, are they clear? Any major doubt? Please ask me. Clear hai pakka? Because then I'll show you the other side of the diagram. Clear? Yes or no? Partly clear? हाँ जी. वेस्ट ईस्ट ऊपर वाले डायग्राम में देखो, ईस्ट वेस्ट. जब आप स्काई से कुछ भी देखोगे सरफेस के ऊपर तो ऐसा ही होगा ना, नॉर्थ साउथ ईस्ट वेस्ट. स्काई से, हाँ, सैटेलाइट पे बैठ के देख रहे हैं जमीन पे. मान लो यूरोप का ऊपर आपका एक सैटेलाइट उड़ रहा है कुछ, और वेट पहले इतना बताओ, ये ईस्ट वेस्ट नॉर्थ साउथ समझ में आया? वेरी गुड. नाउ सेकेंड थिंग, अब क्या नहीं समझ में आया? अच्छा, कोल्ड फ्रंट वेस्ट साइड. और इस वाले डायग्राम में बोलो, विच साइड इज कोल्ड फ्रंट एंड विच साइड इज वार्म फ्रंट? हो गया? चलें वापस? ओके. और कोई डाउट? पक्का क्लियर है? यस और नो? कुछ मतलब थोड़ा इशारा कर दिया करो यार, मुझे ऐसा बोल दिया करो, हाँ सर समझ गया सर. क्लियर है ऑल ऑफ यू? ओके. हाँ जी बोलो, किसका डायरेक्शन? ये बेंड क्यों हो रहा है? अच्छा, ये ऐसा बेंड होकर के यहां से यहां तक कैसे पहुंच गया? हाँ, ये इधर देखो, यहां पे क्या बनाया हमने, ये इफ यू आर पुशिंग दिस थिंग, दिस लाइन, है ना, ऐसा करके आप पुश करें, ये वर्टिकल बेंडिंग नहीं है, मतलब ये जो बेंड होके ऐसा हुआ है कर्व, ये वर्टिकल, ऐसा वर्टिकल वाला ऐसा नहीं, जमीन पे जो खड़ा हुआ ऐसा बेंड हो रहा है, नहीं, ये हम मतलब द होल शेप, द होल वॉल इज बेंडिंग, देयर इज अ वर्टिकल वॉल एंड दैट वर्टिकल वॉल इज कर्व्ड। तो ये पूरा वर्टिकल वॉल है ऐसा, लेकिन वो थोड़ा सा बेंड शेप है, वाई, बिकॉज द विंड इज पुशिंग, तो सेंटर में विंड ज्यादा पुश करेगा, तो पूरा का पूरा वॉल ऐसा बेंड हो जाएगा। हाँ, ठीक है, मतलब सपोज दिस इज द फ्रंट, राइट, ऐसा है, तो ये फ्रंट ऐसा बेंड नहीं हो रहा है, ऐसा ही है, बट ये ऐसा बेंड हो गया, ठीक है, सीन फ्रॉम अबव ऐसा बेंड हो रहा है। कैन यू इमेजिन एवरीवन? सो दैट्स दिस बेंडिंग दैट आई हैव ड्रॉन, this one is like this, it is vertically standing, almost vertical, but it is somewhat shaped like this, and this one is shaped also and it will also be bent this way, ऐसा आगे की तरफ ये bend होगा, ठीक है, clear है, right? All right, now so if I try to draw this thing, अब now I'll try to draw you this diagram, okay, and then so let us number them 1 2 3 4 and try to draw all of them, 1 2 3 4, okay, and I'll add each of them. So what will 1 look like? वो जो 1 वाला डायग्राम है, seen from above 1 is like this, ठीक है, ऐसा ही है ना, 1 seen from above, and seen from on the surface of earth, what would it look like? This is tropopause and this is the surface of earth. So you can see two fronts here, one the east one, which is the warm front, ये वाला, and the second the west one, which is the cold wala, somewhat like this, seen on the surface. Is this clear? ट्रोपोपॉज थोड़ा सा टेढ़ा है, ट्रोपोपॉज को भी सीधा कर देता हूं, ठीक है। सो ऑन द सरफेस ऑफ अर्थ एंड ट्रोपोपॉज, दिस इज द ईस्टर्न एंड वेस्टर्न, ठीक है। सो दिस साइड व्हाट एयर, वार्म एयर, मुझे लग रहा है ये कुछ मतलब कुछ सर ये दो डायग्राम आपने मिक्स कर दिया है, कंफ्यूजन हो गया, इमेजिनेशन में कंफ्यूजन कि कैसा इमेजिन करना है, हॉरिजॉन्टल या वर्टिकल। एक काम करो, ये वाला भूल जाओ अभी, बस इतना ध्यान रखो। इज दिस ओके? कैन यू सी दिस वार्म फ्रंट, राइट, एंड द वार्म फ्रंट इज ऑन द विच साइड, eastern side, and can you see this cold front, and the cold front is on the western side, and can you see the gap between them? Why is the gap? Because they are still not overlapped, overlap nahi hue, theek hai, they are far away from each other, therefore there is a gap. Is this clear? So what kind of air will I have on which side? The air here is warm, ye wala air, and this side cold, and this side also cold. यही सीखा था ना आपने, वार्म कोल्ड फ्रंट, अपना डायग्राम में चेक करो, समझ में आ जाएगा। इज दिस ओके? डाउट है तो बोलो बोलो, प्लीज प्लीज आस्क, ऐसा घबराना नहीं है। देखो, देयर आर टू डायग्राम्स दैट आई एम एडिंग नाउ, दिस इज वन डायग्राम, दिस इज द सेकेंड डायग्राम, दिस इज द वार्म फ्रंट डायग्राम, दिस इज द कोल्ड फ्रंट डायग्राम, एंड बोथ ऑफ देम आर एडेड, दैट्स इट। अपना दोनों डायग्राम देखिए, कोल्ड फ्रंट, वार्म फ्रंट, यू विल रियलाइज कि वो सर ने सिर्फ ऐड किया दोनों को, एंड बोथ ऑफ देम आर अवे फ्रॉम ईच अदर, तो डिस्टेंस है दोनों का बीच में, ठीक है। दिस इज इक्विवेलेंट टू डायग्राम नंबर 1, सो दे आर फार अवे फ्रॉम ईच अदर। कैन यू अंडरस्टैंड दिस? अब नेक्स्ट टाइम क्या होगा, द टू फ्रंट शुड कम क्लोज और गो अवे, कम क्लोज, फिगर नंबर 2 में दे आर कमिंग क्लोज, ठीक है ना। सो इफ आई जस्ट ड्रॉ इट लाइक दिस, तो ये फ्रंट यहां पे आ गया एंड द सेकेंड फ्रंट विल कम क्लोज टू इट. As compared to that, these are closer. And this is your cold air. This side also cold air, and in between warm air. Right? So in the second diagram, the two fronts have come close. Why? Because this one is moving east, but this is moving east faster. The cold front is moving faster and the warm front is moving slower. So the two of them come close to each other. Diagram number 2. ठीक है? Major doubt? No? Third diagram में क्या होना चाहिए? They should come more closer. And last diagram? They will overlap. Should I draw the overlap directly? Third diagram छोड़ सकते हैं? हाँ? या नहीं चाहिए सर, वो बना दो. ठीक है. So थर्ड डायग्राम का स्पेस आई एम लीविंग, ओके, ताकि अगर बाद में कोई मुझे बोलेगा नहीं सर वो चाहिए अब, तो आई कैन ड्रॉ. बट SOF is what? Surface of Earth. Okay. East to west. सब कुछ पूछना पड़ता है सर. एक चीज तो बहुत क्लियर है, सरफेस ऑफ अर्थ. बाकी भले समझ में आ रहा हो या ना. हाँ? अच्छा, F हो गया. SOE ठीक है. थैंक यू यार. सरफेस ऑफ अर्थ में ओके. So, and where is the warm air and all? ये वाला डायग्राम में you have to see the 3 or 4 diagrams together so as to understand कि ये हो क्या रहा है. Okay, so when you see all the 3 diagrams together, you get a sense of what is happening. Can you see here? All the 3? At least वो 2 देख करके भी समझ में आएगा. Cold air, warm air, and then when they overlap, where is the warm air gone? Upper atmosphere. And on the surface, which air do I have? Cold air on both the sides. Can you see? And what has happened to the front? The two fronts have overlapped. ठीक है? सिंपल, अंडरस्टूड, क्लियर, क्लियर. हाँ जी, डाउट है? बोलो बोलो. कोल्ड फिर से बोलो. द एयर ऑफ कोल्ड एयर मास, ये कब पढ़ा हमने? दैट द एयर ऑफ कोल्ड एयर मास गोज अप. कॉपी में चेक करो क्या लिखा है. पढ़ो पढ़ो पढ़ो. विच एयर गोज अप. यही सब छोटा छोटा डाउट्स हमारे ना क्रिएट होता रहता है. एक हाँ बोलो बोलो, रीड. मैंने ही लिखवाया, मुझे पता है क्या है. लाइटर वार्म एयर accumulated on the margin of cold front. वो कौन सा एयर है? देखो कौन सा साइड का एयर राइज हो रहा है? कोल्ड फ्रंट का या वार्म फ्रंट का? कोल्ड एयर मास या वार्म एयर मास? डायग्राम में है ना. कोल्ड एयर फ्रंट नहीं, कोल्ड फ्रंट. दिस वन, ये वाला, ये थोड़ा सा कर्व, ये इतना सा कर्व क्यों हो रहा है? अच्छा, मैं कैसा बताऊं आपको? हाँ हाँ, वो हो सकता है, वो थोड़ा ज्यादा हो सकता है. इट इज सिंपल एज, सपोज आई एम ट्राइंग टू पुश समथिंग लाइक दिस, ऐसा. ठीक है, एज आई गो ऑन पुशिंग विल आई बेंड फॉरवर्ड ऑन टू इट बाई पुशिंग और शुड आई बेंड बैकवर्ड? आप किसी को धक्का मारते मारते उसके ऊपर ऐसा चढ़ जाते हैं, या कुछ ऐसा धक्का मार रहे हैं तो धीरे धीरे अपना आपको पीछे बेंड करके और उसको आगे धक्का मारते जाएंगे? इमेजिन। अब डिपेंड करता है कि सर मैंने लाइफ में धक्का मारा ही नहीं है, तो एक बार धक्का मारना है आज किसी चीज को, ठीक है? आज एक दीवार के साथ खड़ा हो जाना, दोनों हाथ ऐसा रखना, हंसने का जरूरत नहीं है। सी दीज आर यू कैन बी राइट कि सर कई बार हम धक्का मारते मारते ऐसा आगे भी झूक सकते हैं, जैसा आपने ठेला वाला को देखा होगा, है ना, कि कई ठेला वाला बेचारा धक्का मारता रहता है तो वो रोल हो रहा है तो अपने आप को पीछे कर करके ना वो ऐसा स्लोप एंगल करके एंड देन ही पुशेस। बट इफ यू आर स्टैंडिंग स्ट्रेट एंड यू आर ट्राइंग टू पुश समथिंग, ओके, जस्ट इमेजिन, तो ऑब्वियसली आपका थोड़ा सा बेंड, क्योंकि हर जगह से फोर्स आ रहा है, ठीक है, तो वो बेंड बैकवर्ड होगा, आगे नहीं, तो वही वाला वो बेंड है। किसी डायग्राम में हल्का ज्यादा बेंड दिखा दिया, ठीक है, बट वी स्टिल से दैट इट इज रिलेटिवली मोर, कोल्ड फ्रंट्स आर रिलेटिवली मोर वर्टिकल। थ्योरी बुक्स में कहीं पे ही पढ़ोगे तो क्या लिखा होगा? कोल्ड फ्रंट इज रिलेटिवली मोर वर्टिकल एज कंपेयर टू वार्म फ्रंट, ठीक है? अभी ठीक है? आगे वाला फिगर में कौन सा वाला? ये वाला? अच्छा, यहां पे ये वाला, वो वही कर्व बताया ना कि थोड़ा थोड़ा कर्व होता जाएगा, क्योंकि आप देखेंगे तो बाकी जगहों पे वो एग्जैक्टली स्ट्रेट वॉल नहीं है। यहां पे आपको इक्वल लग रहा है, ऊपर ऊपर, ठीक है, उसमें हमें झगड़ा नहीं करना है, मान लेना है बस, ठीक है? क्यों मान लेना है ये मुझसे मत पूछो, मतलब हम मान लेंगे यार, राइट? वाई? बिकॉज मोस्ट ऑफ द डायग्राम्स आर शोइंग लाइक दैट, तो मैं भी वैसे ही बना रहा हूं और हमें एग्जाम में इतना बना करके काम चला लेना है बस, ठीक है? ब्यूरोक्रेट का जैसा सोचना है, काम चलाना है अभी एग्जाम के लिए, ओके? दे वुड नॉट आस्क यू व्हाई द अपर पार्ट ऑफ द कोल्ड फ्रंट इज बेंट, आई गारंटी यू, लिख के ले लो मुझसे, ठीक है? बिकॉज दे डोंट आस्क यू दोज काइंड ऑफ क्वेश्चंस, तो इसीलिए वहां तक जाएंगे नहीं। ऑलराइट, और कोई डाउट है? नहीं? तो शुड वी कहां तक पहुंचे हम? और इसमें बुरा बुरा नहीं मानना है कि सर ने आंसर क्यों नहीं किया, ठीक है? ओके, अगर आपको इसके ऊपर बुक वुक चाहिए तो मैं दे सकता हूं, लेकिन फायदा नहीं होगा, अभी दे दूंगा, पेन ड्राइव में रखा हुआ है, बट फायदा ही नहीं है, करोगे क्या? पढ़ तो लोगे, टाइम वेस्ट हो जाएगा, ठीक है? सो यस डियर, बोलो। वन कोल्ड फ्रंट इज मूविंग वेस्ट टू ईस्ट, हाँ जी, अगला भी मूव हो रहा है ना, धीरे धीरे आगे जा रहा है वो भी, देखो वो हर डायग्राम में थोड़ा थोड़ा आगे गया है, मतलब ये भी आगे जा रहा है, वो भी आगे जा रहा है। वन कार इज गोइंग स्लो, द अदर कार इज गोइंग फास्ट, पीछे वाला गाड़ी फास्ट है, आगे वाला गाड़ी स्लो है, सो ग्रेजुअली दे विल कैच अप। दो कोल्ड फ्रंट कहां है? कोल्ड फ्रंट तो एक ही है ना। अच्छा, कोल्ड एयर, वो तो फ्रंट, हमें तो फ्रंट का मूवमेंट देखना है, एयर मास का नहीं देखना है, वो डिपेंड करेगा कौन किसको पुश कर रहा है, ठीक है? फ्रंट और एयर मास में भी अंतर है, मतलब ये दो तीन अलग अलग टर्म है, जितना मिक्स करके लिखोगे उतना नंबर, ठीक है? तो नॉर्मली यही होता है, जो आंसर्स आते हैं आप लोगों से उसमें फ्रंट, एयर मास, ये सब मिक्स्ड होता है, तो एग्जामिनर क्या करता है? थोड़ा कम नंबर देता है। कम नंबर का मतलब क्या है? ट्राई अगेन। जब भी आपको मेंस में कम नंबर आया उसका क्या मतलब है? ट्राई अगेन, एक साल और लो, तब तक लेते रहो जब तक हिम्मत है या फिर राइट आंसर देना शुरू कर दो, ठीक है? तो अच्छा, अभी क्या करें? ये लिखना है, कहां तक पहुंचे? हैव आई डिक्टेटेड एनीथिंग? नो सर। ये समझ में आया पहला? यार आपका फ्रंट बीच में कैसे ओवरलैप कर गया है? नहीं मेरे कहने, अच्छा वो नंबर 2 नीचे है, हाँ तब ठीक है। उनका डायग्राम में 1 फिर ओवरलैप फिर अलग हो गया ये क्या मतलब है ना, रोमांटिक कॉमेडी चल रहा है मिला जुदा हुआ फिर मिला ऐसा थोड़ी करना है यार ठीक है, ओके सो Okay. So should we write now? I give you time so that you people can digest. ठीक है, ये deliberately भी मैं कई बार देता रहता हूँ, ऐसा ही घूमता रहता हूँ इधर उधर कि थोड़ा टाइम दो इनको, आपस में डाइजेस्ट करने दो, थोड़ा गप्पे मारेंगे कि एक दो बार डायग्राम देखेंगे, है ना, डाउट आएगा, पेज टर्न करेंगे, फिर समझ में आएगा ओ शिट ये क्या पूछने वाला था होता है ना कई बार ये राइट. सो आई हैव टू गिव यू दैट टाइम so that you know gradually digest and then move on. So should we move on? Complete overlap होगा अभी आ रहा है, वो डायग्राम लास्ट में बनाएंगे. Okay. So should we write? लिख लें इतना. Please do. Start as we see, and please put numbers as 1 2 3 4 only. Figure number 1 2 3 4. Okay. वो जो पहले वाला था 1 2 3 4 और इसमें क्या है 1A 2A and 4A. 3 तो हमने किया नहीं है, ठीक है. 1A 2A and 4A चलेगा. ये देखो ये कौन कौन सा डायग्राम है 1 2 3 4 and what is this 1A, this is 2A, 3A we did not draw and directly 4A. ठीक है. So I'll go in that sequence, right, and if I need I will say 3A also. वो आपको इमेजिन करना है, इतना ये सब करते रहना है लाइफ में, कोई बात नहीं, इमेजिन कर सकते हैं. जो जो नहीं बनाया लाइफ में वही इमेजिन करना होता है, ठीक है. सो शुड वी राइट? लिख लें. ओके, राइट डाउन. as we see in figure 1 2 3 4, as we see in figures 1 2 3 4, as the warm front and the cold front, as the warm front and the cold front move in a west to east direction, warm front and cold front move in a west to east direction, the warm front moves slower than the cold front. Warm front moves slower than the cold front, and hence gradually the cold front overlaps with the warm front. Cold front overlaps with the warm front. Figure 4 overlaps with the cold front. The cold front overlaps with the warm front. Figure 4. All right. Then next paragraph. As we see in figure 1A, 1A is ये वाला diagram. As we see in the figure 1A, on the east of the warm front, what air mass do we have? East of the warm front, which air mass? We have to write. On the east of the warm front we have the cold air mass, comma, on the west of the cold front, we have the cold air mass. तो दोनों तरफ cold है. West of the cold front we have the cold air mass, whereas between the cold and the warm front, we have the warm air mass over the earth's surface. Between the cold and the warm front we have the warm air mass over the earth's surface. Okay. And the warm front, between the cold and warm front we have the warm air mass over the earth's surface. Is this okay? यहाँ पे देखो ये कौन सा एयर है? Between the cold and the warm air mass over the earth's surface. Which figure? Figure 1A. 1A लिखवाया है ना, ठीक है. Now next, whereas when the fronts overlap, when when the fronts overlap as shown in figure which 4a, as shown in figure 4a, when the fronts overlap as shown in figure 4a, on both sides of the overlapped front, on both sides of the overlapped front, near the surface of earth, on both sides of the overlap front, near the surface of earth, we have what air? Which air? Cold air mass. Cold air mass. ठीक है? Cold air mass. Whereas all the warm air mass, has what? Lifted up. All the warm air mass has lifted up. ठीक है? Now this lifted up air mass, what will it cause? When the warm air will rise, will it cause rain and all? Yes. So this will cause, but after once this warm air is completely lifted, is there more warm air below to rise? No. So what will happen gradually? Cloud formation will come to an end and the rains will also gradually come to an end. Why? Because all the warm air is already lifted. So whatever cloud they can form, they will form once that is over. अब नया warm cloud कहाँ से आएगा? There is no warm, where will the new warm air mass come from? है ही नहीं. All the warm air mass is already lifted. Is this clear? So on the surface, what condition do you have? On the surface, both the sides of the front, overlapped front, what condition do you have? Cold air mass, दोनों तरफ ही cold air mass है. So there is no rising warm air. So cyclone will gradually become strong or weak? Weak. आ रहा है समझ में? So the cyclone will become weak. What about front? This overlapped front, on both the side of front, what type of temperature is there? So if both the side same temperature is there, front becomes strong or weak? Weak. So the front will also become weak. The cyclone will also become weak. Do you get it? So gradually that cyclonic condition comes to an end. So starting from stationary front, the cyclone started to build, and when the front overlap, the cyclone begins to end. So from beginning to end, that's the story. And what do you call this overlapped front? Should I call it as a weak front or strong front? And hence we also call it as the death of the front. ठीक है? Frontolysis word use करते हैं इसके लिए. Frontolysis. Frontogenesis means, genesis मतलब beginning. So कब होगा? Stationary front. That is frontogenesis. And this is frontolysis, end of front. उसी तरह से cyclogenesis and cyclone end, or lysis or whatever we call. Do you get it? आ रहा है समझ में? So this front, we have a new name for this. When the front ends, there is a new name. उसका क्या नाम है? Occluded front. Right? So a dying front is called as a dying front, is also known as occluded front. Does that answer your question? ठीक है? So do you get it? तो लास्ट में जब ओवरलैप हो गया तो occlusion हो गया. Clear? And occlusion is also called as frontolysis. ठीक है? So what have we written? Last line, can you read?
Surface of air we have cold air mass, whereas all the warm air mass has
Lifted up. Should we continue to write further? लिख लें आगे. So write down. Hence, the overlapping of the front brings the cyclonic condition to an end. Overlapping of the front brings the cyclonic condition to an end. Okay? And hence gradually the cyclone will be over. Full stop. Also, on both sides of overlapped front, on both side of overlap front there is cold air, both side of overlap front there is cold air mass, and hence the front will also become weak, hence called as occluded front. Front will become weak, hence called as occluded front. OCCLUDED, occluded front. Underline number 4. This is the fourth type of front. Okay, so these are the 4 types of front, and this is the cyclone formation and the end and all. Is this okay? Do we get? Now answer this one question from me. In this case, how many cyclones will simultaneously form? One or more? What did we learn? Did we form one cyclone or we form more than one cyclone? Which were they? कौन कौन सा है? Cold front cyclone and warm front cyclone. Both will form together. So whenever temperate cyclones will form, cold front cyclone and warm front cyclone will form together. Where will the cold front cyclone be? East side or west side? Cold front cyclone, west side. And where will the warm front cyclone? East side. And how big is this structure? Do we know? This can be as big as 1000 to 2000 kilometer wide. So one cyclone might be at one place, maybe 1000 kilometer wide system. Another cyclone maybe 1000 kilometer away, behind or westward, and that might be a cold front cyclone. So you have 2 cyclones moving together. Is this okay? Clear? So itna samajh mein aa gaya? Any major doubt? None? ठीक है. So I won't push you any further today. I'll leave you here. Reason being, हाँ जी? Slide 1. कौन सा वाला? अच्छा 1 2 3 4 ये वाला? Okay. Right. I'll give you other things in the next class. Do we have a class tomorrow? ठीक है, तो कल करते हैं. And tomorrow we are also doing tropical cyclone. So please read your tropical cyclone part and come so that we can complete it. And tropical cyclone के बाद फिर we'll go beyond to other things such as tornadoes etc. तो वो सब बाद में करेंगे. ठीक है? Hopefully you have written this much and most of you are clear. Go back, read, revise and come back. ठीक है? Any major doubt? If you have, you can ask me. If you don't have, you can leave. ठीक है? Sir, anything online you want me to take up? Nothing? ठीक है. So this is where we end today. That's it. Thank you. The ones who have doubts, किसी किसी को मैंने कहा था ब्रेक के बाद आना या क्लास उसके बाद आना, वो सब आओ. बाकी जाओ.